Hey everyone, in Docker course we learned how Docker helps us package application into something called containerization and run them consistently across environments. Right? Now let's suppose you have deployed an application that needed 5 containers to continuously running. Suppose one of the container crashes at 2 a.m. in the morning. So do you wake up and restart it manually, or would you prefer a system that does it for you automatically? When any container crashes, it will create automatically a new container. So that's where Kubernetes comes in. In this series of the chapter, we will try to cover all the aspects of Kubernetes. As this is a beginner course, we will not go in depth of the Kubernetes concept, but we will try to cover all the basic concept of Kubernetes, and we will also try to practice all these things in our own lab VM. So I would also request you to please go ahead, set up a lab VM and practice it with me, because watching lectures only won't help you in mastering Kubernetes. Okay, with it, let's start. So there are some prerequisites for this course. First, you should have a knowledge about YML configuration file. If you want to learn about YML, I have provided a quick info or quick brief on YML in my Docker course, which is in my playlist. I will also try to provide the link of my Docker course in the description. Also, if you want to learn YML separately, I have the course of YML in 30 minutes in my playlist. The next one is containerization tool, that is Docker, and you need to be aware of containerization technology, how it works under the hood. If you are new to containerization, I would suggest you to please don't directly come on Kubernetes. I would request you to first navigate and learn about Docker and the basics of containerization, and then come on Kubernetes. The next one is must needed, that is your practice VM. You need to have a practice VM in your hand. I would not suggest you to go ahead and install these things or install Kubernetes directly on your main laptop, right? Please go ahead and create a Linux VM, because if you are going to enter in the DevOps world, you need a Linux VM to practice on it. If you want to learn about Linux also, I have the course in my playlist in which I have covered all about Linux, especially Ubuntu, from basics to advanced. Okay, now I am hoping we have these prerequisites covered. So let's move ahead and let's learn what we are going to cover in this course. So first, we will have some quick recap to containerization technology, how it helps and how it works, and also its challenge, what challenge we might face when you are using only containerization tool without any other orchestration tool or without any cloud provider. In the next chapter, we will learn about what is Kubernetes and why do you need it, what is Kubernetes and what it is not. So we'll try to discuss all of those. In the chapter 3, we will learn about Kubernetes architecture and its base components and how these components helps us in communicating the isolated environment to each other. In the chapter 4, we will set up our Kubernetes in our VM, and then we will try to run, and then we will start running our commands of Kubernetes, and we will also try to write and deploy our configuration file of Kubernetes. In the chapter 5, we will start our Kubernetes core concept, its working, and how it works under the hood, along with the demos on our VM. In the chapter 6, we will learn how you can manage data and volumes in Kubernetes. When we were discussing about Docker, we have seen that Docker also provides some kind of volume and managing of data in hand, right? But that might not help if you are going to orchestrate various type of containers together. So we'll learn about various type of volumes supported by Kubernetes, and there are vast variety of volumes supported by Kubernetes. In the chapter 7, we will learn about Kubernetes networking. There are various type of networking supported if you want to connect two clusters together, two servers together, two nodes together. So Kubernetes provide you an option for that. In the chapter 8, we will take our Kubernetes to one step above for its deployment. Alone, Kubernetes can deploy your infrastructure in your local environment, but if you want to use it and if you want to really use it in your production environment, you should consider it to integrate it with cloud providers like AWS and Azure. and then use it to deploy your apps. So we will see that also. In the chapter 9, we will see from here where you can go next, what you can explore more, and how you can master Kubernetes after covering all these core concepts. Okay, so with it, let's start our chapter 1. In this chapter, we will learn about containerization. We have a quick recap. If you want to learn about containerization in depth, please go ahead and navigate to my Docker course. With the quick recap of containerization, we will understand what are the challenges that you can face if you are using only containerization tool for deployment of your app in your local environment. So first, let's understand traditional methods without containerization, how it was working earlier. So suppose this is my host OS, my workstation, my local PC, and if you want to run any application that you are going to deploy it or you are going to install it. Suppose there is another application and it needs a dependency, and if you want to deploy another app that needs same binaries and same dependency but it needs a different or higher version, then how you will achieve this? So for that you cannot deploy on the same host, right? What you will do, you will create or you will purchase a new VM or new instance of a server or new workstation, and then you will try to run app separately. The another traditional method is we have use of VMs. You can use something called hypervisor that provides you flexibility to create a VM. Now these VM are isolated to each other, right? So you can deploy your application on each VM one by one so that you don't need to go to and purchase any another infrastructure ahead. But still, there was disadvantage that these VMs needs a guest OS to run. So that was a heavy weight, and they need some time to boot up, boot down, or to distribute resources from your host to your VMs. So that was also a disadvantage. So to overcome this, we have something called a containerization technology, in which, similar like your hypervisor, we have something called a container engine. In case of Docker, we have Docker engine. Now these Docker engine provide you an environment to run some these application, something called an isolated environment containers. You can run different containers side by side, and then these are completely isolated, so if you are installing any app in this container, they are not going to affect or communicate or affect any dependency in your another container. They are completely isolated to each other. So that's how container helps. But still, containerization tool alone, if you are using only Docker, so it might not help, because suppose if you want to deploy 100 of container more, so you are going to write some command manually and then you are going to deploy it, right? And you are going to start each container one by one, right? To overcome this, we learned Docker Compose. Docker Compose was an orchestration tool that we can use to manipulate multiple containers or multiple virtualized environment at the same time, right? Now, the Docker Compose also had some limitation, and similar like Docker Compose, we have something called Kubernetes that we will discuss in this series of the chapters. Okay. Now we have understand about containerization here. Let's understand about its limitations. The first one is scalability. Suppose suddenly you got a demand to increase your infrastructure or increase the instance of your application. So you are going to manually do that. There is no way to automatically scale up or scale down your infrastructure application automatically, right? That needs a manual intervention. The second point is load balancing. With multiple containers of the same services, you must manually set up reverse proxies like Nginx for the load balancing, so that it will try to connect from one front end and it will try to communicate with the another backend. Also, the containers get dynamic IP, so tracking and updating them manually is also error prone. The next one is high availability and fault tolerance. So suppose if a container crashes, Docker won't restart it unless you configure restart policies. Also, there is no self-healing option. You must monitor and restart containers manually. If you want to talk about rolling update is like you are providing a zero downtime to your end user. So these are very tricky and tedious in this kind of infrastructure if you do not have any orchestration tool in hand. Next one is configuration and secret management. You would have to pass environment variable manually, the secrets and configuration file manually while deploying your application or infrastructure, right? Also, there are no centralized way to manage these keys or variables or secrets, right, across the containers. The next problem is we have network complexity. So setting up multiple host networking containers across different services is very painful. Also, manually overlay network setup or tunneling is required to connect containers across your different servers or different environments if you have multiple domains. Next one is resource management. So there are no built-in way to enforce CPU or RAM utilization across a cluster. Containers also might compete for resources if multiple containers are running on the same host. So they might need to struggle with each other that, hey, I need this much resources, but you need this much resources. So can you provide me resources to me? So these are also not built-in functionality of the containerization tool. So these were the limitation if you are using containerization tool alone. Again, I am talking about only containerization tool alone. If you are going to integrate it with cloud, so many of the limitation would go away. But we are not going to integrate here with the cloud. Okay. So that's it for chapter 1. Let's meet in the chapter 2 with what is Kubernetes and why do you need Kubernetes, what Kubernetes and what it is not. Okay. So let's meet in the next chapter. Till then, take care. Hey everyone. Using containerization tool alone can have some limits like a scalability issue, load balancing and service discovery, high availability and fault tolerance, configuration and secret management, network complexity and resource management. And we have seen these examples in our previous chapter. Now to overcome this, we have something called Kubernetes that provides inbuilt features to overcome all these limitations. But suppose if you don't want to use Kubernetes for your solution and if you want to have another option, so you have first option that you can integrate your packaged app or your pre-built image with cloud providers like Azure, AWS or Google. In the last chapter of our Docker course, we have seen how our package or build image was used to deploy a app on our Azure app service. Similarly, you can use your packaged app with another cloud service providers also. Now these cloud providers will automatically provide you container health checks plus automatic deployment. Suppose your company wants to regularly check for the health probe or health events related to your packaged app. So they can use the inbuilt functionality or inbuilt feature that is provided by these cloud providers. Also, if you want to increase or decrease based on the demands, so you can use auto scaling feature provided by these cloud providers. Third is load balancing. If you want to route any traffic to any particular backend, so the cloud provider will provide you these functionality inbuilt also. Next one is self-healing. Suppose if any container fails and first it will try to boot up. If it does not, then what it will do, it will try to create a new instance for it. Again, for using all the services, you are going to pay for them. Also, once you have start using these cloud service provider services, then you are bound to that specific cloud service. Suppose if you are going to like any particular service of AWS and if you want to integrate it with your existing Azure's integrated services for your container, you cannot integrate them. Next one, if you want to use their services using suppose CLI, then you need to learn about all the modules that they have. Also, you need to install their CLI. You need to learn about their specifics, what they does, how they does, what different options they have, what different arguments they have, also different type of services they provide, and the configuration that you want to make on your local host or your target host. So these are the limitation when you are using your packaged app with cloud provider. In case of containerization technology, it does provide you containerization orchestration solutions, but it does also have some limitations. Now to overcome this, we have the ultimate Kubernetes. Now in here, you can tell Kubernetes, so sometimes also it is referred as It is referred as K8 and S. So how it stands, the K is for the first letter and S is for the last letter, and in between there are 8 letters. So instead of writing Kubernetes whole, we used to write K8S. Okay, so K8 is also the use term for Kubernetes. Now if we will talk about Kubernetes, Kubernetes is independent of cloud services, means it's completely work independently of cloud services. Although it was originally designed by Google, it is an open source system for orchestrating container deployment. So now you have finally a solution for maintaining and to working with multiple container at the same time, and it's an open source, means it's freely available. Anyone can install it on their system and start using it. Now in here we have two types of approach. First one is imperative and declarative. Either you can go ahead and run one single command to achieve your goal for deploying your container or to manipulating your container environment. But suppose if you have a complex architecture that you are going to deploy in your container environment, so you will need to write something called a configuration file in which you define your services, kind that you are going to use, and all the various options that it has supported. Now, once you have deployed or written in your configuration file, and of course, you will write in your YML language. Okay, now you write your code. So either you can deploy it on your local environment, means if you are going to use it for the test purpose, or if you have a server also for your company, you can deploy it on a server so that the other managed user in your company can use them. Or if you want to extend your functionality more, not even limit to the Kubernetes, and if you want to integrate or make more complex architecture, then you can integrate it with your cloud also. But please be informed, integrate Kubernetes is open source, but integrating it with the cloud, it's not free. It's not open source. They are going to cost you whatever services you are going to use for the Kubernetes. So if you want to use Kubernetes alone, it's completely free. But if you are going to use Azure Kubernetes services, that is a mirror of Kubernetes services on the Azure platform. So it is going to cost you depend on what are the CPU or SKU that you are going to use it. The next one is you need to understand why Kubernetes, as it is that it's limiting your Docker containerization tool alone will comes with some limitation. So to overcome this, we have Kubernetes and we have various type of feature that it has supported inbuilt, and it's completely open source. The first one is load balancing and service discovery. Load balancing is like if you want to load balance or distribute the traffic within your environment or within your cluster, the Kubernetes provide flexibility of it. Another one is service discovery. So basically you can use or expose a port of your containers using their DNS or IP, because by default they will be able to communicate with each other. Now there are two terms, we will try to cover them in our components and architecture chapter. There are two terms. So if you are deploying a container in Kubernetes, it is called as pod. Okay, pod. Now the pod does not runs individually. They needs a node on which they can be run. Now one node can have multiple pods, but for the best practices, one node can contain only one pod. So this running environment in your containerization tool was just a container, but in Kubernetes, it's a node running your pods. Okay. Second one is storage orchestration. So basically, you will mount a storage system of your choice within your cluster or within your container orchestration system. Third one is automatic automates rollouts and rollbacks. So basically, you define your desired state, even updating your image, how many instances that you want, and it will do it for you in the background. It will just take couple of seconds and it will try to roll out all these things in there. The fourth one is automatic packing. So in here, what it will try to do, unlike our containerization tool, which it has the fixed resources for each container, in here you can define your own resources like CPU and memory for specific containers. Next one is configuration and secret management. So Kubernetes does provide you management of your password, token, keys, or coupons. Okay. Next one is batch execution. You can integrate with the help of CI. Basically, they are helpful if you want to integrate it with your CI workloads so that it will run one task one after the another, or if you want to run them parallelly. So you can define them as a policy in your configuration file. Next one is horizontal scaling. Basically, scaling up and scaling down with a simple command or GUI or based on a spike you can achieve in the Kubernetes. And at last and most important, IPv4 or IPv6 dual sticks. So basically, this functionality of Kubernetes allocates IPv4 and IPv6 addresses to ports and services so that you are not limited to only IPv4 addresses. You can extend the functionality using IPv6 also. Okay, so whatever the limitation that we have in our alone Kubernetes tools, that is being covered by our open source ultimate tool that is called Kubernetes. Okay. Next one, let's learn what is Kubernetes exactly and what it is not as an overview. The first one is not cloud service provider. Many folks get confused that it's a cloud service provider, but it's not like Azure, AWS, Google, although it's an open source and it can be integrated with your cloud service provider. So in your configuration file, you define some annotation or some resource provider module so that you can define that, hey, I am going to use my this configuration file with the help of my Azure. So you define one line and your configuration is going to be used with the cloud services. Okay. The next one, it's not just a software installed on your host. It's set of tools and concept that you are going to use for orchestrating your containerization environment. Next one, it's not an alternative containerization tools called Docker. Means it's not like that. It does not work like Docker. Basically, it works with Docker or any other containerization tool to improve your functionality. The next one, it's not paid service. As I already mentioned, it's an open source. Anyone and anywhere can use it for deploying their orchestration environment for your containerization tool. Okay, so I'm hoping you are clear with Kubernetes and its basic concept. Now let's move ahead and let's start our journey. Let's understand what is Kubernetes architecture and its component, and how these components are working in the background. Hey everyone, and welcome to chapter 3. In this chapter, we will learn about Kubernetes architecture and their components and how they work in the background with Kubernetes. I'm hoping you went through chapter 1 and chapter 2, in which we have talked about Kubernetes basics and how it is come on the top of your containerization tool. So now let's move ahead and let's first understand the Kubernetes architecture. The first one that your Kubernetes and its components reside on, it's called a cluster. Now this cluster is you are going to define and you are going to create. We will see this when we will be trying to set up our Kubernetes from the beginning. This cluster contains a control plane, which kind of a master, which is responsible for going and managing all your aspect of Kubernetes objects. Now in Kubernetes, the objects refers to a different type of entity that you are going to create as a service. There will be a control plane which will be kind of a master node, and also you will have a set of worker machine that are called nodes. Now these nodes will run your containerization application. Every cluster needs at least one worker node in order to run pods. Okay. Now we will come to pods later. Let's understand the components in the control plane or the master plane that going and responsible to manage your whole Kubernetes components. First one is Kube API server. So basically this is a API server component of the Kubernetes that exposes your Kubernetes API. This is the main and the master of all the managing aspect of your resources, it's going to communicate using Kubernetes API. The next one is etcd. So basically, it's a key value pair of all the data that is being stored in the cluster, and it's take the data from Kube API server. Okay, it will take the data and it will store it in it. It's just a key value pair. Next one is scheduler. This component of control plane will watch for newly created pods. Basically, the pods. So, if you I will talk about pods, so pods is basically your instance of running container. Basically, one or two pod can be run in single node or a working VM. Now, if I will talk about scheduler, so basically, this component of control plane will watch for any newly created pods running instance of your application with no assigned node and selects a node for them to run on. So if there are any newly created pod that is being created, so it will select on which node it is going to run. The next one is controller manager. It is also one of the key component of your controller plane. Basically, it consists of many tasks. The main tasks are node controller and job controller. Node controller is like responsible for noticing and responding when any nodes go down. So whenever any node or your working machine will not work or unresponsive, so it will get notified to your Cube API server and it will stop executing that process. Second component of controller manager inside this control plane is job controller. So basically, it watches for job object. So we will see about the object. You can create different type of object in Kubernetes. We will see that. So the second part of controller manager, that is job controller, has the job for watch for job objects that represent one of task that create pods to run those tasks to the completion. The next thing is we have Cloud Controller Manager. Basically, it's communicate both with your Kube API server and your cloud provider API. Okay, so basically, if you want to integrate anything in your Kubernetes config file using their cloud provider API like Azure API, and you can integrate that. But how Kubernetes will manage it? So will manage it with the help of Cloud Controller Manager that is inbuilt with control plane in your cluster. Okay. Now coming to the nodes or your working machine, so they will definitely have a CRI, the container runtime instance, which is basically a interface that is running your pods. Okay, so you can either have one or two pods, you can have only one pod, and also you can have a volume attached to it. Okay, now how these controller or how these nodes are going to communicate with your Kube API server or control plane, right? Because they need to be communicated with. So that's when the kubelet comes into the play. The kubelet is like an interface or an agent between your nodes and Kube API server in the control plane. This agent that runs on each node in the cluster, it will make sure that containers are running in a pod. Then next, you can have an optional component also running on these nodes that is called kubeproxy. Basically, it is a network proxy that runs on each node in your cluster, implementing part of a Kubernetes service concept. So basically, these are the networking part for your node and for your cluster. If you want to expose a port to your node, to your existing machine or a local machine or any server. Okay, so that's what the kubeproxy is used for. Now, I'm hoping you are clear with these components and this architecture. Now, let's move ahead and let's see these components again. Let's understand about them theoretically. So first let's discuss about control plane components. This is a master component which will make decision about the cluster as well as detecting and responding to cluster event. Controller plane can be any machine, but by default if you will not configure it, so it is going to be your host on which the Kubernetes is installed. Okay. The next important part in the control plane is Kube API server. The API server is a component of the Kubernetes control plane that exposes the Kubernetes API. So whatever services or whatever application that you are using nowadays, they are being connected or they are being used by their service using API. Similarly, Kubernetes also have their API. Now to communicate with your Kubernetes resources, you need something that communicate your Kubernetes API to your services or your underlying infrastructure or underlying configuration. So that is what the Kube API server is for. Basically, it's also called a front end for your Kubernetes control plane. By default, if you will not set it up, if you will not configure it, so the default implementation is horizontal scaling of the ports and also traffic balancing. The next component in control plane is etcd, consistent and highly available key value store used as Kubernetes backing store for all cluster data. So these are not like a relational database, these are just a key value pair that is being stored. The next component is Kube Scheduler. So this is a control plane component that watches for a newly created pods with no assigned node and select a node for them to run on. So if there is a newly created pod, so Kube Scheduler will look for that newly created pod and it will assign it to a node on which it is going to run. So each pod should be associated with at least one node, and one node should at least have a one pod. The next component is Kube Controller Manager. So basically, this component that runs controller process, and it is of basically four types. Now we don't need to worry about last two, the endpoint slice controller and service account controller. For now, let's understand only about these two, that is the node controller and job controller. The node controller is responsible for noticing and responding when any node go down, and it will inform the master plane or the control plane, and it will act accordingly. The next component is job controller. Basically, it's versus for a job object that you have defined in your configuration file and you have asked Kubernetes to deploy it. Basically, that represents a one-off task at one time, right? And then creates pods to run those tasks to completion till the end. The next component is Cloud Controller Manager. We have seen this, right? So basically, it also consists of three dependencies. First one is node controller, then route controller, and service controller. And what is this component is actually? So basically, that embeds cloud specific control logic. The Cloud Controller Manager lets you link your cluster into your cloud provider's API. If you want to attach or link your Azure, so you can just provide an annotation in your Kubernetes deployment file. You just write your one line for using the Azure API and it will deploy the infrastructure for you and it will deploy the applications for you. Now the following controller can have cloud provider dependencies like node controller, route controller, and service controller. The node controller is for checking the cloud provider to determine if a node has been deleted in the cloud after it stops responding. The route is for setting routes in the underlying infrastructure if you have defined load balancing and other stuff. The service controller is for creating, updating, and releasing cloud provided load balancers. The next one is your node components. So we have seen this. There are only three components. The first one is kubelet. So basically this agent that runs on each node in the cluster, it makes sure that containers are running in a pod. So it's responsible for running your containers in your pod. Okay. So if I will also talk about an overview, so each pod will have the container running associated with that application and those pod will be associated with a node. Okay. So node is containing a pod and then pod is containing the container or containers. All right. The next one is proxy. This is an optional if you are going to expose your deployment or your nodes to your external cluster or internal cluster, then you need proxy. Third one is container runtime, which is responsible for running your containers or pods. So I'm hoping you are clear with Kubernetes architectures and components. With it, let's also understand what you can create, means what is your work in this architecture, what you should create, and what Kubernetes will create for you. Okay, what's Kubernetes work? So first let's understand what is your work. So you need to create the cluster and node instances based on your configuration that you will define. So you need to define your worker plus master node. If you are not going to define anything or if you are not going to set up anything, so by default it will use your machine, your host, to create a cluster on it, and also the node instance, the virtual node instance on it. The next one is you need to set up API server, kubelet, and other KH services or software on your nodes. So suppose if you are not defining any default node and if you are setting up your own nodes, so you need to define the API server and set up the API server, the kubelet service on those nodes. Okay, so you need to install them. The Kubernetes is not going to connect those external nodes and it's not going to ensure that kubelet is going to be run on it. Also, it's your work to create other cloud provider resources that might need it, example load balancer and mount services. If these resources are needed in your Kubernetes configuration file, then it is you that you needed to create it. The next one is Kubernetes work. So based on your configuration that you will define in your YML file, so Kubernetes work is to create your object like deployments of pod and then also to manage them based on what you have defined or mentioned. Also, it is going to monitor your pod, recreate upon failing based on the policy you have defined in your configuration file, and also it's going to scale up, scale down based on your traffic. Also, K8, the Kubernetes utilizes the provided cloud resources to apply your config or goals. So if you have set up your service principal or the API for your particular or the specific cloud, so it is going to use it and it is going to apply your configuration or goals depending on your whatever you have specified. So I am hoping you are clear with Kubernetes architecture and its component. So now let's move ahead and let's start setting up our Kubernetes on our Linux VM, and let's start using Kubernetes services. Let's create some things and let's finally use Kubernetes to get our hands dirty. So let's meet in the next chapter. Till then, take care everyone. Hey everyone, now we are aware of Kubernetes architecture and their components. If you haven't gone through that chapter, please go through and watch it and let me know if you face any difficulty while understanding any of the components. So after this, let's get started and let's start setting up our Kubernetes on our VM. So just to be clear, so just to a quick recap, in the Kubernetes architecture, we have seen that we need to set up a cluster, right? In which we have a control plane which works as a master node, and then we need to set up something called a node or a worker VM. Now, if you are going to do this manually on your platform in your development workflow, so your company might need to set up all these things manually. Okay, and then they need to install the required software or tools that is needed on control plane like Kube API server, and on the node it's kubelet, right? So they can make sure that they are going to install it. Now the alternative is using cloud provider technologies. Okay, so suppose if you don't want to set up your cluster, your worker VM, or your master node or a control plane, then you can use cloud services to manage your Kubernetes services or any deployment. So what these cloud services will do, these cloud services will cost you of creating a control plane and pods or nodes in the background. You just define how many nodes you want, how many cluster you want, and they will create for you. Now, if I will talk about two leading cloud technologies, we have Amazon and Azure. The Amazon provides Amazon Elastic Kubernetes service. You can register for this, you can log in with your AWS account and you can start using it. The another alternative is Azure Kubernetes Service. This is also a managed service for Kubernetes by Azure. So in here also you just define how many cluster you want, what's their SQ, and the Azure will take care of the rest. All right. Now, as we are going to fully practice it, so we are not going to utilize our cloud tools. So what we can do, we can set up some kind of a local environment on our VMs or on our local workstation and set up a cluster within, and then we can set up a control plane node or your Wacom VM. So what we are going to do, instead of using cloud services, because that's not our agenda for using cloud services for creating these things, what we can do, we can use our local machine or local VM that you use for your practice or for your lectures. So you can use that to create a cluster, control plane and worker nodes. Okay, so let's see how we can achieve this. And with the cluster, you also need a tool called kubectl or kube control or kubectl. Okay, so two things we need. First one is the cluster, and the second one is kubectl. That is the command line utility, so that we can send our command to cluster to manage our Kubernetes deployments. Okay, now to achieve this, we will try to first install kubectl in our VM, and I will show you the illustration of Kubernetes setup in my Linux VM that I am using for illustration on my all the courses on my DevOps channel. So I will be using my Linux VM itself for deploying these Kubernetes and whatever practice I will do. But alternatively, I will also show you how you can set up Kubernetes in your Windows VM. Okay, unfortunately, I don't have Mac OS that is currently functional. I have that, but it's too old. So just follow me along, follow the instruction on the Mac OS page, and let me know if you face any issue. I will definitely try to help you. For now, let's see the installation on Linux and Windows. So let's move ahead and let's see the Kubernetes setup and installation on Linux. Okay guys, now I am on my Ubuntu VM that I use for practice and that I use to record all the session. So I will open my Chrome here and I will search for K8's installation. I will go to this one, install tool, which is at docs, task and tools. It will tell you what tools that you need to run Kubernetes on your workstation. Now, once you land to this page, so it will tell you how you can use it. So the first and mandatory tool, if you want to communicate with your cluster, you need kubectl. Although if you are using Minikube, you don't need this. You can set up an alias to use kubectl inside this Minikube cluster. But I would recommend you to go ahead and install this kubectl tool. Now with this kubectl, you have three ways here to set up your cluster. Okay. Now this one, these three-way kind, minikube and kubadium, it will, whenever you will follow this step, it is going to create a dummy cluster inside your main VM. So currently as I'm using Linux VM, so what it will do, it will try to create a VM with as a cluster for my Kubernetes, and it will also create dummy nodes inside it. So if you are using Docker, then you can use kind to set up and start using Kubernetes. The Minikube is easy way. The Minikube is basically it will check your resources, and depending on the resources, it will create a cluster for you. Okay, and the third one is KubeADM. But I would request you to first go ahead and install the kubectl and use Minikube for further proceeding ahead. So first, let's try to install kubectl. If I will go to my terminal and if I will type kubectl hyphen hyphen version, so I don't have kubectl here. Okay. And it's also giving me to install it from here, but I would not go ahead with this. Let's follow the official method. Okay. I will right click on this and I will click on open tab. Now on this page, I will go ahead and I will use with native package manager. Now first I need to update my repository. So I will type sudo app update. I need to provide the password. In your case, it might take some time. And as I have already updated my package, so it will not take much time. Now I need to install some packages for certificates, curl and GNUPG, and I suspect that I have already installed them in my earlier lectures, okay, as a prerequisite. So yes, they were also installed. Now I need to check whether this repository exists or not. Okay, this particular directory. If it does not, then I need to create. So let's go ahead and let's become a sudo user first. And let's navigate to etc. And if I will list, so if I will type tab after cd, so I don't, okay, I have that tab cd apt. If I will list, so I have keyrings. Okay, so I have keyrings, so it's good, I am okay. If you don't have keyrings, then you need to go ahead and run this command. Okay, so it will create that file. In my case, it's have it. Okay, now I will exit it from my root because I don't want to get install minikube from my root user, and I will clear the terminal and I will follow next. Now I need to download the public signing key so that I can use my Kubernetes package. I can verify them. So first I will copy the first command and I will right click on it and I will paste this command. So once it has added my public key, now what I can do, I will change the permission of it. It is also done. Now I will follow next. Now in here, this is the step for adding the appropriate Kubernetes app repository if you want. And if you also want, you can change the version to whatever version you need. For now, I am going with the default and it's basically adding the repository to my repository directory. It's just adding the Kubernetes directory, okay, from where we look for the packages. Now it will also try to change the permission of this list so that it should be able to check for the packages. It's also done. Now we are good. We need to again type sudo apt update because you have just added Kubernetes in your package, but we have typed this. We have checked our all the packages before adding it, right? So now we are checking for any update packages related to Kubernetes after adding our list. So let's check. Now you can see that it will also give you the list that it's checked in the Kubernetes also. Okay. So all packages are up to date. I am good with it. Now I will install kubectl. So I will go ahead and I will type sudo apt install -y kubectl and it will start installing because we have provided -y and looks like it's done. How you can verify? I can verify it with kubectl hyphen version. Let's not give hyphen hyphen. So now you can see the client version is this one and this one is this one. Now this one is we don't need to worry about. It's talking about the API version that is going to connect to your cluster. So currently it's saying refuse because we haven't set it up. But you should see this client version. Okay. Now we have installed kubectl. Now I will close this window and I will come and I will use Minikube. You can also use Kind and KubeADM, but I would suggest you to go ahead and use Minikube because by default it will set up cluster with a master node and a worker node by default. So I will right click on it and open in a new tab. I will go ahead here. Now I will go, and as this is my Linux VM, I will also show you for my Windows. I will use Debian package. Okay, and it's giving the commands, so I will not copy all of them together. I will go ahead and I will copy the first command. It will take and download the package from this link with the name as minikube latest md dev. Now it might have on my home directory. Now I will go ahead and I will try to unpackage it. So I will copy it. Now it will start unpacking and it has start setting up our all the configuration in the background. To start using Kubernetes, you just need to start minikube. Okay. Now keep in mind that if you will go in here, so you can just type minikube and start and it will start your cluster. But I would suggest you to go ahead and specify a driver. So basically what is a driver? So minikube is by default will check for whatever the hypervisor configuration that you have and it will try to use that one. If there is any misconfiguration, it will try to execute and it will stop it. Hence, I would request you, if you have VirtualBox installed, then go ahead and type driver VirtualBox. But if you have Docker already installed, so you can use Docker as a driver also. Okay. So here it's telling preferred will be Docker. And also in my Docker course, I have run Docker and I have done all the illustration of Docker in my this machine itself, means Docker was installed. So Docker hyphen hyphen version, or if I will type Docker PS, so it is running, right? So it means that Docker is installed. Now I will start my minikube cluster. So I will use minikube start hyphen hyphen driver equal to, if you have VirtualBox installed, but in my Linux VM, as it's a VM, so I haven't installed Oracle VirtualBox. But if you want to use it, you can go ahead and just type Oracle VirtualBox. So you can use that one also as a driver. So you can go ahead and type on download and it will, you just check your packages and install accordingly. Okay, just hit next process. But I'm not going to use my VirtualBox in my Linux. In my Linux, I will use Docker as a driver. But in Windows, I will try to use a Hyper-V, because in Windows we have Hyper-V as an option too. So in Windows you can either use Hyper-V. If Docker is installed, you can use Docker or VirtualBox. So I will try to use Hyper-V or Docker. Okay, but in my Linux, let's try to use Docker. So I will go ahead and I will type Docker in all in the lowercase. If you have VirtualBox, then just type VirtualBox. If you have Hyper-V, then just type Hyper-V. Okay, so for now, I will go ahead and type Docker and I will hit enter. Now it will give you all the instruction and it will also give you what are the memories and vCPU that this minikube cluster is going to take for your cluster. So let's wait for it to boot up because it might take some time. Also, you need to make sure that your VM or your laptop or your local workstation on which you are running this command, it should have at least 2 vCPU free and 2 GB of RAM free. So that's it, the minimum. But I would go ahead and suggest you to go a way more above so that you don't face any performance issue. Just ensure that you have 4 vCPU assigned to it and more than 8 GB memory assigned to it. Okay. Now you can see based on the configuration of my VM, it has assigned 2 vCPU and 3 GB of approx RAM to my this container. Now why it is telling Docker container? Because it is going to spin up a VM on my Docker container to create a cluster, because in my cluster I need definitely two VMs, right? One is a master and one is a worker VM at least, right? So it's going to use Docker container to do all these things. Now you should see done. You should not see any error. If you are seeing any error, then you should try changing your drivers. Okay, for me, it's done. Now what I can do, I can type minikube status and I should see all these things in running and configured. If there is anything stopped, that means it is not configured correctly. Also, you can see whatever the resources you are going to create through minikube using minikube dashboard. So it will start a local API on this local workstation. It will give you the link from where you can access it. Okay, so let's wait for the dashboard to be launched, and it is giving that it's open on this one. I will click on this one and it has opened this one. Now you can see that it has already detected in the default namespace. We will come to these things already later. Now, if I will go in here, you can see there is nothing here to show you here. Okay. But if we will try to run anything in here, it will show you as a dashboard also. Okay. So that's how you can verify it. So I will cancel it and I will also verify if I can use cube CTL get pods so that I don't get any error. So yes, we are good. We have seen that no resources found in the default namespace. It didn't give an error and it is telling that no pods were created, so we are good. So I'm hoping you are clear with your installation of Kubernetes on your Linux VM. Moving forward, I will be also using my Linux VM only for working on Kubernetes. Okay, for illustrating you all the concept of Kubernetes. So now we are done with Linux installation of Kubernetes on Linux. Let's move ahead and let's see how you can install and configure Kubernetes on your Windows workstation or your Windows laptop. Also, before you leave your workstation, ensure to delete your minikube cluster. Okay, if you are not using it, else it is running and using resources in the background. So if I will see my systems monitor, you can see it might be still using my CPU and memory for that. Okay, because it's still running. So what you can do, you can type minikube and delete. So it will delete all these things, all the container, and it will free up your space. So now we are finally done with Kubernetes instruction and setup on Linux. Let's move ahead and let's try to set up and install Kubernetes on a Windows platform. This could be either your Windows VM on which Docker or Oracle VirtualBox is running, or a Windows laptop on which Docker or Hyper-V is installed. Okay, so let's meet in the chapter where we will see the setup and installation of Kubernetes on Windows. Hey everyone, in this chapter, we are going to see how we can set up and install Kubernetes on our Windows VM. So if you can see, I already have Oracle VirtualBox installed, Docker Desktop installed, and also the Hyper-V also might be installed. So if I will check for the feature, so in here you can see Hyper-V is not selected, but you can select this Hyper-V option to enable hypervisor platform, but I will not do that. Now, how you will follow along, how you will set up the installation. I will go to my browser and I will search for install Kubernetes. Okay, and then I will go to the very first link that is coming from docs, task and tools. I will click on install tools. And as I suggested in my earlier chapter, that for working with Kubernetes, you need two things. The first one is kubectl, that is the utility that you are going to use to communicate with your cluster. And the second thing that you are going to need is your cluster. Now the cluster, you can go ahead and create and install all the tools that the cluster require, the node or the worker VM is required manually. Else, you can go ahead and use these features to create a dummy cluster and or dummy worker VM for you. So with kubectl, you can use a kind. So it will also give you, so basically it works with Docker. The second option is you have Minikube, in which you can define many driver like hypervisor, Hyper-V. For Windows, you can define Hyper-V, or for Oracle VirtualBox, you can define VirtualBox. Or if you have Docker installed and if you want to use Docker to deploy a cluster, means create a VM inside your Docker container that will be used as a cluster, so you can go ahead and define as a driver in the Minikube. Similarly, like in our Linux setup, we will use Minikube in our Windows also. Okay, but first let's install kubectl on my Windows. So I will click on install kubectl on my Windows. I will go to this very first link, and I have two options here. Either I can directly download the binary from curl, you can directly download it, or we can use a package manager called Chocolatey, which helps and makes easier for installing any package management for these kind of things. Okay, so in this case, what I will do, I will use Chocolatey package manager. So I will click on right click on Chocolatey, and I will go here and I will click on try it now. Now once if I will go here, I need to copy this command and that's it. So I will go ahead and I will use PowerShell as admin, and then I will paste this link. Now it will start installing Chocolatey in the background. So let's wait for it to get Chocolatey installed on my machine. Now looks like we didn't get any error, and also we are ready to use Chocolatey. Now to use Chocolatey as a package manager, you need to close the window and you need to reopen it again. So PowerShell and run as administrator again. Now once the PowerShell is open, now we can type this command to install Kubernetes CLI, that is kubectl, using package manager Chocolatey. So we can just type choco install Kubernetes CLI. So now it will start installing kubectl, that is Kubernetes CLI, as per our Chocolatey. Okay, now we need to type yes, and it will start installing all the tools in the background. Now it is going to take some time and looks like it's done. Now how I can verify the version? I can type this one. You should see the client version. If you are not seeing it, that it means it was not installed. So you need to check what it has created the issue. Now next, we need to create and we need to go to our home directory and we need to create a directory called .cube. And inside that .cube, we need to create a file, an empty file called config, that is going to be default for all the Kubernetes config. So whenever you will start your Kubernetes, it will look for a config file inside the .cube directory. If there is not, then it will throw an error. So this is a step for Chocolatey, but if you are going to use another method, you don't need to create them because the script will do it for you. All right. So now as I am from my, I think, PowerShell. So let's see this. So I am on my home directory. Now either I can open or let's try with mkdir dot cube. So now my mkdir dot cube directory was created. I can type dir. So you can see my dot cube directory was there, right? Now I need to navigate to this directory. So cd dot cube. So I am inside my dot cube and I don't have anything here. Now I need to create a file. So let's create this file. So this should work in PowerShell, but if you are using command prompt, then I think it should not work. Now if I will list dir, so I have config file as an empty. Also, you can verify it using your file explorer. So inside here, I will go to MSI and then I need to go to .cube and then you can see that empty config file was created. So we are good. Now, once the kubectl is installed, the next one is we need to move ahead and we need to create a cluster. So again, as I said, for cluster, we will be using Minikube. So let's see the installation guide of Minikube here. I will close the other tabs. Now inside here, I will select Windows x86-64 stable and I will click on exe download, or either I can use Chocolatey because I have already installed Chocolatey. So I will use Chocolatey itself. I will click on copy and I will install PowerShell, run as administrator, and I will right click on it and I will hit enter. So now it will installing Minikube for me in the background. So let's wait for it to get installed. Now looks like it has installed. Now what I can do, I can go ahead and install the next stuff, that is Minikube start. Now for starting your Minikube cluster, you should specify a driver also because I think it might not work, but let's see. So you can see it is using Docker desktop driver with root privilege. So you can see it has detected that Docker desktop is running, right? And it has used my Docker desktop driver to create a cluster. So we can also select the driver as Hyper-V, VirtualBox or SSH if you want to use another cluster in your infrastructure. So for now, it is using my Docker desktop and it will create a cluster on a VM and that VM is going to create using Docker container. So let's wait for it to get open and get it running. And based on my CPU specs of my Docker container, so you can see that it is using 2 vCPU and approx 4 GB of memory itself. If you want to specify your own memory and RAM, you can also do that. We will see this in the upcoming chapter. So now it is preparing our Kubernetes and it will use all the APIs on all the tools that needs to run on the containers for Kubernetes API, kubectl on my Docker container. So it's using Kubernetes and it is trying to use their services in my Docker. Okay. Now looks like it was done. There was no error. How I can verify? I can verify using Minikube status. So you can see all these things are running, right? If you want to see the dashboard, also if I will go to my Docker desktop, so you can see by default it has started a cluster called Minikube and it has checked the image of Gates Minikube and it has opened all the port. Now what this port will do, this will give you the dashboard. So how you can also verify that? I can also type here Minikube dashboard. Okay, so now it will start and create a dummy dashboard just like you are seeing in the Docker desktop, in which that dashboard will be for your Kubernetes. So this dashboard is for your Docker related stuff, means you are seeing that Minikube has created a container inside your Docker, right? Similarly, for your Kubernetes, it will create a dashboard for pods and nodes, whatever the things that you can see. Now by default it automatically redirected and you can here see all the things here if you have created one. Okay, so as we haven't created anything, so it's still empty. But if you don't want to use CLI method to check everything and you want a UI method, then you can use it. So Minikube give these features also. Okay, so that's it. That was the installation on Windows. Let me cancel it for closing my desktop and let me delete my cluster. So minikube delete. So now it will delete my cluster and container from Docker and it will free up all my space. All right. Now in here, I was not able to arrange a Mac OS illustration for you. I apologize for that, but the installation on Mac OS is also pretty simple. So first, again, you need to install your kubectl client. So for that, you can go to this thing, and in here you can use a package manager called Homebrew for your Mac OS. Definitely have Homebrew on your Mac OS. So if you have Intel chip, then you can go ahead with this one. If you have Apple Silicon, you can go ahead with this one. Okay, and you can use this command to get the kubectl up and running. So you can let me know if you face any issue, but the installation on macOS is also pretty simple. If you want to use package manager, it will be very easy. Just install Homebrew on your Mac OS and that's it. You just need to run this command and it will do all these things for you and it will install kubectl. So you just need to install Homebrew. Once the kubectl is installed, you can verify the versions. Now once the kubectl is installed, you again need to install Minikube. So you will go to this page. Then in here you will click on macOS. The most architectures are x86 64 and you can use Homebrew because earlier lecture you also installed Homebrew. Again, you don't need any other commands. You just type brew install minikube and that's it. So for your Mac OS, there is only two commands that needs to be run on your Mac OS, but you need to sure that Homebrew is installed on your Mac OS. For installing kubectl, you just type brew install kubectl. Then once it's done, just install brew install minikube. Okay. Now once it's also done, you need to start your cluster and check whether your cluster is running. So you can type minikube start. Now what is the driver that is going to take? So as this was the Windows, so it might take Hyper-V, but on macOS it can only take a Docker or a VirtualBox. So if you have VirtualBox running and installed on your macOS, then well and good. Just type space hyphen hyphen driver equal to VirtualBox. Else, if you have Docker installed, just type hyphen hyphen driver equal to Docker, and it will start your cluster. It will assign the sizes and CPU based on your Mac OS configuration. Okay, so that was the installation instruction for Kubernetes on Mac OS. So please let me know if you face any difficulty. I will be happy to help you. Now let's meet in the next chapter. Let's get this started. Let's practice. Let's create some object for your Kubernetes. And please be informed that all of my labs I'm going to use my Linux VM on which I have installed my Kubernetes, because for all the courses and all the contents that I have uploaded on my YouTube, I'm using Linux VM. So let's meet in the next chapter and let's deploy some object in Kubernetes. Till then, take care everyone. Hey everyone, now our Kubernetes setup is done and I am also sure that your Kubernetes is also set up and fully functional and we are ready to move ahead. So let's move ahead. Let's understand objects in Kubernetes, core concepts of Kubernetes that we can create and that we can play with it. So if I will talk about objects, so we have various type of objects for Kubernetes that we can create, deploy, or we can attach it to some other object. Now, if I will talk about some main components or object for Kubernetes, so we have pods, deployments, services, volumes, networking, and many others more. If I will talk about an overview, so pods are like smallest unit in the Kubernetes architecture, and they will be running inside your worker VM, and they will contain one or more running containers. Next one is deployment. So by default, you are not going to create individual pods one by one, and then you are going to attach or connect them with a worker or a node VM. It is not recommended if you are using Kubernetes. So for orchestrating pod and to managing them, we have something called deployments. We can also create and maintain and manipulate deployments using our Kubernetes. And next one is services. Basically, these are similar like your Docker services, in which if you want to expose your application to outside port or inside the cluster, so you will need service. So basically, they works like a networking, similar like your Kubernetes network. Then next comes volumes. Basically, you can also mount volumes and similar like your Docker volumes, and we have various type of volumes supported in Kubernetes. So we will learn each of them one by one. So as we have some gathered some brief overview of Kubernetes object, let's move ahead. Now let's focus on the pod object first. Basically, these are the smallest unit is Kubernetes that holds and run your one or more containers. By default, you should run one container per pod. If you want, you can create multiple container in a single pod, but it's recommended that you should create one container per pod. Basically, they also shares resources like volumes with all the pods in the same node or a different node. Also, pods are assigned with the by default cluster internal IP that is assigned with the help of Kubernetes services. Pods data are volatile, means whenever, so it's a similar like your Docker containers, means whenever the container are going to stop and reopen again, their persist data will be lost, right? Similar like this similar property is contained by pods also. So why it needs to be restarted? Because Kubernetes will restart, stop, or replace it for you whenever pods get failed due to some reasons. Okay, so that was the overview of pod. Of course, we can create pods individually and run on any worker node and then set up their kubelet and other things one by one and then to connect them to main kube API server. But that's not Kubernetes is for, right? We will create a controller of this pod that is called deployment. So let's understand deployment object also. Basically, these are the controller of your pods, or you can say the orchestration tool for your pods. You define our desired state, how many pods you want, and how many scale of your application that you want, and Kubernetes will do the rest. Also, deployment can be paused, delete, and roll back based on your images that you will define. They also provide scalability option based on the metrics that you will define whenever you will define your configurations. Okay, so that is the deployment object. Now let's move ahead and let's create our very first deployment option, and we will be doing this using our imperative approach. Now, what is imperative approach? Imperative approach in which we will deploy our object using our command line. After this, we will also deploy it using our ultimate declarative approach, and we will follow only declarative approach because it uses YML configuration file to deploy our deployments. Okay, so just to be sure that you should be also aware of imperative approach and CS, some CLI options for these objects. I am illustrating imperative approach. So let's move on our Ubuntu VM on which my Kubernetes is running and in which we have started our minikube clusters earlier. Welcome back. I am on my Ubuntu VM and this is a very simple Node.js application that we will be going to illustrate our Kubernetes deployments. So if we will try to deploy our app and if we will try to initialize it, so whenever we will try to access localhost 8080, so we will see these things. But if we will try to access /error after localhost 8080. So we should get our app crashed because process.exit1 will exit the application. Okay, so that's how we have made it so that we can crash our application too. The next one is Docker file. So we have seen this in our Docker course. So if you haven't gone through that, all these instruction, if you are not aware, then I would request you to first go through Docker course first and then come on Kubernetes. Basically, these are the set of instructions that we will use to deploy our Docker image. So definitely for Kubernetes, we will be needing Docker to be installed and running so that you can build your image using Docker and then you can push it to Docker Hub. So here what I will do, I will type Docker build -t creates app image and then dot to provide the current path. So this is the command for building our image. It will build the image of Kate's app image, and this is the context that we are providing that look for Docker file in this path itself. So we are in this path. Okay, so Docker file is here. So now we will try to build our image. I will hit enter. Now if I will type Docker images, so we can see we have our K8's app image built successfully, okay, with the tag as latest. Now I will also check the status of my minikube status. So it should be running. So yeah, it's running. I will also start my minikube dashboard so that I can see the things in the real stuff. So I will not start here. I will right click on it and I will click on new window and I will use minikube dashboard. Okay, minikube dashboard. We'll start our dashboard also. Let's wait for it. I will navigate to my earlier one. In here, I will clear the terminal. Now you might have remembered the first tool that we installed that was the kubectl. So if I will type kubectl help, so it will give you all the illustration or all the option that is it has supported. So with it, you can create using this, you can expose using this, you can run using this, you can set using this, you can get using this, you can delete using this. Okay, so there are various options supported for my Kubernetes. Now it has also rolled out my Kubernetes dashboard, that is my minikube dashboard. So let it get open in the background so that we can see the things basically in the background. With it, I will clear my terminal and let's try to use our deployment. So I will use kubectl and now I'm not going to create individual pod. I will create a deployment that is going to manage all our pods. So I will use kubectl create deployments. So first I will verify the images of my Docker. So I have this image, right, that I want to use. So I will use kubectl create deployment. Let's give the deployment name as first Kate's app, first Kubernetes app, and I will provide name as image equal to this image names, which is K8's app image. Okay, so once if I will hit enter, do you think it will work? So the answer is no, because whatever the thing or whatever the command that is going to run, it is going to run inside your cluster. Now that cluster is connected to the API server of Docker and all the things related to it. This kubectl is not connected anyhow and not connected to your local system, and it will not look for this image on your local system. So it will try to check for this image either from a private registry that if you can define the absolute path of this registry or else the Docker Hub. So in our case, we will use our Docker Hub to deploy our this image. Okay, so I will use Docker Hub. I will go ahead and log into my Docker Hub account. So I am logged into Docker Hub. I will create a repository here and I will give the repository name as K8's node, and I will click on public repository because my Kube API server should be able to connect to this repository so that it can pull the image, right? I can create image. So I will click on create. Now I am in here. If you will see, so it is asking and giving the command for us to push here. Before that, let's try to tag our image to any other tag. So I will go in here, and as it will not work as I suggested, so first let's tag our image. So docker tag key its app image, the local one, to my docker image or my docker name. Okay, so this one, and I will give the tag name as v1 for now. Okay, so I will hit enter. It was tagged. I will again use this command and I will give, instead of this one, I will give docker push. So it will also, as I have already logged in, so it will trigger a command docker login. So if you are logged out, it will ask for a credential, and now it is trying to push your image. So let's wait for it to get pushed on a Docker Hub so that our Kubernetes will be able to push and pull and look for the images on our repository. Okay, and looks like my image was pushed to Docker Hub. For that, for verifying that, I will go to my Docker Hub and I will refresh this page, and you can see my image is there. So now I am ready to mention and start my deployment using that image. Again, I'm repeating, if you have any image locally, then Kubernetes is not going to detect because Kubernetes is being run inside the cluster inside a VM created by Minikube. So you need to store at any registry. Either it can be a private registry or a Docker Hub. My image is ready. I will clear the terminal. Now here I can create my deployment. So I will go ahead, kubectl, create deployment. Then I will give the name as first K8 app, and then in here I'll provide name as image equal to whatever the image that is being here. Okay, so I will right click in, copy on here, and I will paste here. Paste, and then v1 because we have tagged it to a version also. So I will hit enter, and within millisecond the deployment of our app was created. So if I will type docker, so if I will type kubectl get deployments, so we have our first Kubernetes app and it is 0y1 ready. If we will see about kubectl get deployments again, so it might take some time. So let's wait for it to deploy it. Okay, so after some seconds, now you can see the available is 1, up to date is 1, and ready 1 to 1. Also, it might have created our node or pods, right? So kubectl get pods. So as we have defined only one, so you can see that it is running. Also, it is running on our node that is called minikube, and the status is ready. So it's running on the same control plane that is being controlled, and also it is being running on the same control plane that was created by the minikube. Now we can also verify this by navigating to our minikube dashboard, and now you can see that our deployment pods and application assets are reflecting here, and here is the deployment and here is the pods. So it has assigned a random pod name here. Also, what's the image, the label assigned to it. If I will go to the pods, so it will give you also these details. Okay, so if I will click in here, so you can see the details about all of it. This is the container that is being run, and that is the container name that is being run. So that's how you can use your Minikube dashboard to utilize the details. Now, as of now, we cannot access our application from our local workstation. So for that, we would need a service. So let's discuss service now. So I'm hoping you have also successfully deployed your application and you have created your deployment of your app using Kubernetes. Now let's move ahead and let's understand about service objects that will help us in exposing our cluster externally or within a cluster. Now there are four types of services. First one is cluster IP, that is the default one. It is used for internal communication within the cluster. The next one is node port, which is accessed via nodes IP and port, the particular node IP and port, and they are accessible within the cluster. The next one is load balancer. So if you want to access your cloud load balancer with any external IP that is provided by your cloud provider. The next one and external name and the headless that you don't need to worry about right now. For now, let's only discuss about cluster IP, node port and load balancer. In here, I will move to my Ubuntu VM again and let's create a service and let's expose our application so that we can access and we can check from our local host also. Now keep in mind that pod is assigned with the by default IP, that is the cluster IP. So whenever something happens to a particular pod, so that pod will be deleted and the new pod will be created by the Kubernetes. Whenever this process is being happen, the IP is not persist. The IP will be different. So to persist the IP or to the group of IP, we use service object. So let's go ahead and let's expose our app. So I'm again on my Ubuntu VM on which our deployment is there of Kubernetes. So let's expose our deployment. So I will type kubectl expose deployments. And what is the deployment name? The deployment name is first K8's app. First K8's app. Then I will define the type and the type name here I would here mention is load balancer because we want to access it from our local workstation, right? So if you want to access it and if you want to go inside your minikube and then you want to access it, then you can definitely do that. So how you will do that? For that you can pick the IP of your minikube and you can access the application. But here I am defining using load balancer so that we can check it. Here I will define load balancer. I will define the port as 8080. Okay. Now you can also define node port or a cluster IP. So basically if you will define cluster IP, so you need to get the IP of your minikube. You can do that. We will discuss this about later. So if I will type minikube IP, so this one is the IP assigned to my minikube. Okay. So if I will type to copy it and if I will try to access it using port 8080, so I will not be able to access it because currently it is not exposed. So what I will do, I will try to expose it to any service. So I will hit enter and now you can see this service was created with the name first K8 app and it was exposed. Okay. Also I will type kubectl get services. So I have two services by default. The first one is Kubernetes that was created by default, and the second one is my that we just created. And in here, the external IP is pending because you haven't attached to any cloud service provider. Okay. Now we will expose our Minikube service to this newly created service. So Minikube service first K8's app. So now you can see it has exposed and it has opened our service for our default browser. It might take a second to open the application in our browser. So I will go ahead and if I will go in here, so you can see that it has successfully deployed. So can you verify the Minikube IP? So it's the same like our minikube IP, right? But it has opened the port at through 32015 inside the container of 8080. And now we can see that our application is successfully deployed on our Kubernetes. So hooray, you have made it and you have successfully deployed your application to the Kubernetes using deployment and services. Now let's explore more options and more features of Kubernetes deployments. So the next one is let's test auto heal feature of Kubernetes. So for that, I will again move to my Ubuntu VM, and in here, as we have seen that we have created our application just like whenever we will type error, it should exit our code. Okay. Now, if I will type the status of my pod kubectl get pods, so you can see that it's ready one by one, status is running and restart was 0 because there was no failure. Now what I will do, I will cause a failure to this app by navigating to error page because we have specified here that whenever it will get this one as error, it should exit the app and it should crash this. So I will go ahead and I will hit enter. Now you can see that it was crashed. My application was crashed. I will again go to my this terminal and I will again type kubectl get pods. So once if I will hit enter, you can see the status was error and the restart was 1. It tried to restart but it got failed. So let's try to run one time again. And once if I will hit enter, now you can see it has automatically auto healed our pods that was failed and that caused the error, right? You can see the name is same and also it has caused the restart. So now it took to restart to fix my this pod. So I can close this one and now I can close this one also. So I will cancel this. I will clear the terminal and with it we have tested the auto heal feature of our Kubernetes also, right? Now let's move ahead. Now let's scale our application. Let's create more pods with the help of imperative commands. So how we can do that? So I will verify kubectl get pods. So we have only one pods and that was restarted third time because our it was on our error page continuously. So now in here for scaling and for increasing pods of your deployment, we have command of kubectl scale deployment. And what's the deployment name? The deployment name was so kubectl get deployments. The deployment name was this one. Okay, so let's try to scale it. So kubectl scale deployment. What's the deployment name? The deployment name is first k8's app, and I want to have a replicas of 3. Okay, and I will hit enter and now you can see my this deployment was scaled successfully and now it might be scaling my pods in the background. So for that I will try to use kubectl get pods and now you can see that it within a second of time it has created 2 more pods here. If I will go to the Google Chrome and if I will go to my Kubernetes dashboard, and if I will go to the pods, so you can see it is also reflecting my dashboard. All the details about it is also here, right? Now to balance it, what I will do, I will again go here and I will change it to replicas equal to 1 and it is scaled. If I will check the status, so 2 of them will be terminating. Okay, and now after some seconds, there will be only one pod left for me. Okay. So I will clear the terminal and I will move ahead. Now let's also understand how you can update your deployments. Suppose you have made changes to your application. So how you will update your application too. So for updating that, you have some series of steps. So first, you need to rebuild your image again. Then you need to push it to your Docker Hub with a specific tag. And then While rolling out the update, you need to mention that particular version that you need to roll it out. Okay, so let's go ahead and let's try to modify something. So in my Visual Studio Code, in here, I will try to provide exclamation mark more. I have provided 4 exclamation mark and I will save it. Now in here, what I will do, if I will list the files, so I should have my Docker file in here, right? So I will type Docker build. Instead of creating a local copy of image, we can directly push it to our Docker Hub and also we can create it. So let's do that. For that, what I can do, I can type docker build -t, then the user ID of my Docker Hub account. Okay, this one, and let's tag it to v2. And I will also specify the context that is look for Docker file in the current path. So I will hit enter and it was done because it uses some steps as a cache. Now what I will do, I will also push it with the same command. So I just need to change it build to push and I will hit enter. So it will try to push all the layer to my Docker Hub. So let's wait for it to get pushed to all the application on my Docker Hub. Okay, so looks like it was pushed. If I will go to my Docker Hub and if I will refresh my page, so I have my another version of application pushed to Docker Hub. So first let's verify the deployments. So kubectl get deployments. So I have my this image ready, right? Now let's try to update our image. So for updating our image, we have command kubectl set image. There is another way also for changing your image or updating your image. We will see that later. Kubectl set image, and what's the image that you are going to change it to? So we are going to change it to my deployment, which has the name of first k8-app, right? Then in here we need to define our container name because we are going to update our image on container, not on a deployment, not on our node. So basically first we will define our context. So we are going to define and we are going to check inside deployment. Then on where you are going to update that image. So we are going to update the image on container. So for checking the container name, I will go to my Kubernetes dashboard and I will go to pods. I will click in here and in here I will go to my container name, right? So this is my container name and I will copy the container name. Okay, and it has picked my image. Now I need to update my image to whatever version that I have took here. So I can take the image from here, copy and then paste. Okay, so kubectl set image, whatever the deployment that we have specified, then our container name because my image is going to update on my container. So now I will hit enter. Okay, I think it is unable to find any container with named kube API access. So let me verify. So let's try to describe our app. So kubectl describe, that is also one command. Deployment first k8's app. So in here we can look for a container name. So here is the container name and the container name that is called is k8's node. Okay, so we were doing wrong. It's a k8's node. That's how you can use Kubernetes kubectl describe command also. So that's k8's node. So let me go through that command again and let's just specify k8's node. Okay, so I will hit enter and now you can see our image was updated. I will go to my minikube dashboard also and I will refresh my page. Now you can see it is terminating and it is creating another pod based to define on the updated image. Okay, so now I think it's running, so we should be able to verify our application too. So let's do that. So minikube service first creates app. So now it will open our browser to check for the application. So let's open that. And now you can see we have four exclamation mark that we have just created. So that's how you can update your application using set image command. Now let's move ahead. We have seen how the self-healing works, how we can update our images. Now let's see rolling back our deployments and also see the history of whatever the deployments that we have done so far. So I will go to my Ubuntu VM, and in here, if you will go to your Kubernetes dashboard, and if you will go to the pods in the events, you can see all the details about what the things which was done on the particular pod. If I will go to this one, and if I will type kubectl get pods, so now you can see it has bring out a very new pod, right? This is a new pod from the earlier one, and the earlier one was deleted. Now, if you want to roll it back to the previous version, so how you can do that? You can type kubectl rollout undo then deployment and the deployment name. So first K8's app, right? So once if I will hit enter, so you can see that it's being rolled back. If I will go in here and if I will go to my pods, so now you can see that is being running. And the V2, the pod that was created on V2, it's being in terminating, and the previous version, just the previous version of application is now running. So it was rolled back 25 seconds ago. So it has rolled back our changes. So that's how you can also roll it back. Now there are various options so that particular set of application or particular set of node VM should run the current version and the another set of worker VM should run the updated version. So you can also implement that. There are various way for that we will discuss later. If you want to see the rollout history for this particular deployment, so you can see it using kubectl history command. Okay, so we have two revisions as of now that we have done so far. If you want to roll it back to a previous revision, so how you can do that? You can type kubectl rollout, and then if you want to see the history of any version, so you can type hyphen hyphen revision equal to 3 or 4. If you want to roll it out to a particular version, so what you can do? You can type undo and then hyphen hyphen 2 hyphen revision equal to 2. Okay, so if you will do that, so it will be rolled back and the things will be here also changed. So now you can see our updated, the earlier one was now in terminating state, and again the second revision was roll it back again. Okay, so I'm hoping you are clear with these concepts. Now we are done with imperative approach, and from moving forward we will be understanding only declarative approach because they provides maximum functionality and also they are very useful. So now before moving with the declarative approach, I will deploy all the stuff that was created using imperative. So for deleting it, we have command called kubectl delete. First I will get the name of my deployments. Deployments. So let's delete it. Kubectl delete deployment. First k first k8's app, so it will delete my deployment. And also if I will get services, so I can just type svc. So I have these services by default, so let me delete my these services. So kubectl delete service first gates app. Okay, so my service was also deleted. Now we are ready and we are good to move with declarative approach for creating our objects. So let's meet in the next chapter. Using imperative, we have seen how we can update our deployment, how we can scale our deployment, and how we can roll back our deployments, right? Now let's move ahead and let's do all of these things using declarative way, because moving forward, we are going to use this method only for managing and for creating our objects. Now, till now, we were using imperative way, means one line command to managing and to creating our object in Kubernetes, like if we want to run our pod, if we want to expose our pod, if we want to scale our deployment to 5 or 6 replicas, or whether if we want to change an image, or whether if we want to create new deployment. So with all of them, we were using an imperative command like your CLI command. The disadvantage is it is hard to reproduce, track, or roll back, or even for sharing, it's not feasible. While it's good when you want quick for testing and it just need a one-time change. On the other hand, the declarative way that we are going to use it something uses a YML file or sometimes JSON file in which you define your object that you want to create, the API version and metadata and the spec that you are going to use the desired state for your objects. Once you write it, you just write command kubectl apply f and the file name with the YML configuration. Now it does not need it to be deployment.yml. It can be anything, okay? But the extension should be YML or YML. Now there is also advantage and disadvantage associated with it. The advantage is easy to version control, review and automate with CI/CD as YML is mostly used for it. This one also self-healing, means we just need to reapply the file using the same command and it will be done. Whatever the change you will make to this configuration file, you just apply this command again and it will do and modify these things for you. Now, there is some disadvantage like it is slightly more upfront effort to write YML unlike your imperative command. But moving forward, we will be using declarative way because it's a recommended way whenever you are practicing any technology or any tool. Now, in declarative way, we will be using this moving forward. We are not going to use imperative way. Basically, this contains a YML or JSON configuration file. These are easy, rewritable, shareable, and orchestration and updating objects made us easier using this declarative way. Whenever you will write your YML file, it is contain 4 mandatory field that is needed for sure. The first one is API version. Basically, you can find about this API version from the Kubernetes reference docs. I will show you when we will be on our Ubuntu VM. Here you define which version of Kubernetes API that you are going to create this object. The API version varies time to time, but from some years for deployment there is a stable version that is currently as of now, which is apps forward slash v1. Now the Kubernetes API, suppose if it has a latest API version, then you should use that one because it might have some improved functionality, any bug fixes, and more features supported to it. The next mandatory field that you should provide in your configuration file is kind, in which you define the type of your object, which is your deployment or a pod or a service. Next one is metadata, in which you define your name or a label to your object that you are going to uniquely identify. And the fourth important field is spec. Basically, it states your desire for the project. For example, for your deployment, you will include your containers specs inside this spec. Okay, so these were the mandatory field that is definitely needed for sure whenever you will write a basic object. Now, these mandatory field also varies on the type of object that you are going to create. Whenever you are done with your configuration file, you will write kubectl apply -f filename.yml. Now suppose if you have bunch of file and if you want to apply it, so you can use -f again and then the file name, then -f file name. So whatever and how many times you would like, you can mention it. Also, suppose if you have bunch of files and if you want to apply all the files in the same directory, you will just type -k with it. So we will see this in the upcoming chapters. So now let's move ahead on our Ubuntu VM and let's create our deployment using YML file. Okay, so I am on my Ubuntu VM. Now in here, I will first verify the status of my minikube and I will ensure that everything is looking fine and good. So yeah, it is. Now I will also verify the deployments that I have so that I will not get confused and I will delete the earlier created deployment using my imperative command, right? So kubectl get deployments. So there is no resources. We will come to this namespace thing later in the section. And then we have kubectl get pods. So we have no pods also. Means we are good and we can now write our deployment configuration file using YML. So I will move to Visual Studio Code and in this same directory I will create a file called deployment.yml. Okay. Now in here, whatever the thing you are going to use, so you can just search for the web if you are not able to find them. So in here you can search about Kubernetes deployment YML. You can search for these kind of things here and you can go to this very first link by Kubernetes and you can go inside here and you can see that you have some dummy YML file given as an example on the documentation. Also, if you want to look about various option, which option you should integrate here. So for that, you can go to the reference, then you can go to Kubernetes API, and then you can go to workload resource, and then you can go to whatever the resource type you want to create. For example, if I will go to deployment, so it will give you the option of all the option that is a test supported. So API version that you should mention, the kind you should mention, the metadata. If you want to learn more about it, then go to this link. The spec and also the status if you want to mention. But these four are the mandatory field. Okay. Now there are also various options supported like what you can mention in the spec section. So selector that is required, the template it is also required. So also based on the type of object that you are going to create, the mandatory field also get changed. But by default, these four fields are needed for sure. Okay, so you can go to this link and you can go for deployment and check what other option that it has supported here, right? Now in here, I will go to my Visual Studio Code and I will start writing my YML configuration file. As I said, the first line is API version and I will mention it as apps/v1. Now, if you want to not sure and which API should you use, so you can go to the official docs and you can look for the whatever latest version they have. So currently also they have only apps/v1. Now our first mandatory field is done. The next one is kind. What kind of object that we are going to create? We are going to create deployment. Now next one is metadata, which will help Kubernetes to uniquely identify our object. Now this metadata in which we have several properties in here. Now what several properties it has supported, so you can go here and you can just open this object metadata, and it has various options like name, generate name, namespace that you can mention, and the annotation. This annotation is basically used for your cloud service provider mapping. Okay, now we will also use labels and we'll use name. So let's go ahead, and as it as a sub value inside it, so I will use a dictionary or key value pair. Now in here I will use name. This name will be the same like whenever you were going to create imperative command of deployment, so you were using kubectl create deployment and then you were providing some name, so that is the same name here. So here with the name I will provide k8's app, then the deployment name. Okay. Now after it, we have next one, which is a spec. So in this, we will be providing our details about our containers or pod that we are going to create. The first one that you should mention is replicas. By default, it will take one. So I will also mention one for now. And then we will specify template. If you will go in here in the deployment section and if you will go to the spec section, so it will redirect to you here. Now in here it is asking that it's required a selector and a template for sure. Now the selector is like a label that you are going to assign to your pods or the containers. So I will not add selector right now, but I will leave the column for it. For example, in here I will leave the selector here as a blank, and I will come later and I will add here. Now let's first add template because we are going to add our containers first. Okay, so here is the container, and what is the template that you are going to use? So we can always click on this link inside it and it will take here. Now what are the mandatory field here? So you can go here and check for whatever mandatory field that they have supported. Okay. So for now, I will just go with the minimal options. So in the template, I will mention metadata, metadata. Then in the metadata, I have bunch of options, right? First one, I will assign it to labels, and I am going to assign it to labels called app key value pair second app. Now in here, you can add another label here like your SQ is prod or dev, or your environment is dev or prod, or you can also create an expression for your labels like match expression, and you can match your expressions instead of labels of key value pair. So that is some advanced topic which we will try to discuss this later. For now, let it assign with only one label. Okay. Once we have defined labels, after it, what we will do at the same level of my metadata, this one, my metadata, I will define spec. Now, this spec will be for my containers that is going to be run. Now, this spec will be for my container that is going to be used. The first one is the spec for my deployment, and now whenever you will specify template, that it has also some required properties like your metadata and spec and other things that we will within the spec. I will define containers. Now this is the individual pod specs. Within this container I will define the name. I will provide the list because I can have multiple container running inside the pod, so I am providing the list. Now what is the name of the container that you are going to give? So I will give like node fun. And what is the image that you are going to use? So in here I will be going to use DevOps channel 23, and I will verify the name or the images. So Docker images. So I have the latest image of this one. So DevOps channel 23, K8 node and V2. If I will run currently, it will throw error because this deployment is not bound to any pod. It is just going to have like your master plane, and it is not going to select which node or which pod it should select for. So for that, we have the selector section. Now in the selector section, what you can do, you will mention match labels so that it will check for these particular labels on which this deployment will be run. And what is the labels that we want to match? We are going to match this one, which is app is going to be second app. Okay. So let's quickly go through it again. The first line of the deployment will be your API version, then kind, then metadata and the spec. That is the four mandatory field of any object that you will create in Kubernetes. Again, for any kind of object, if you are not sure what option that does it has as a required field, so you can always go to the reference docs and you can navigate to all the properties. Now in here, by default, I will define a replicas because the spec also contain some mandatory field like replicas, selector and template. So for spec, I will define replicas as one. Then I will also use selector. Then the template. The template basically used to define its own structure of the containers. Now this template also needs a metadata and a spec as a mandatory field. In the metadata, we have defined a labels of app, then second app, because suppose if we are going to create a network and volume. Now, how Kubernetes will understand that it should attach to this pod or container that is going to use. So that's what the label is used for. And then we use spec, the containers, which is of name. We have assigned the name of the container and then the image name, right? Now this should be not the image from locally built. It should be on any private registry cloud or a Docker hub. Once we have defined our labels, we should also use it in the selector section because our deployment will not check on which node it should get run or which node it should select to get run. So we will specify selector, match labels, and then the key value pair that you have defined as a labels. So once I have done that, I will click on save. I will go to my terminal. I will clear the terminal. I will again verify the deployments. So I don't have. Now I will apply my configuration file. For applying the configuration file, you should be at the same repository. So for that, I will navigate to it. CD downloads, CD K8 node. Now if I will list, so I have my deployment.yml file here. What I will do, I will use kubectl fly-f and then my file name. Okay. So once if I will hit enter, it will check and it will look for all the dependency or whatever the syntax that you will got and as an error. If it is not, it will give you, it will check for the API and it will give you that deployment dot apps means you used deployment dot apps. The app name is Kate's app was created. If I will verify my deployment, so now I have Kate's app ready and up and running. If I will also get to kubectl get pods, so it is now up and running fine. I'm hoping you are clear with how we can write a basic deployment file and how we can start it. Currently, we cannot access our application, but we still need our service, right? So now let's move ahead and let's create our service also so that we can connect to our app using our web browser, and we will create our service using declarative or YAML configuration file itself. Okay. So I will again go to my Visual Studio Code, and in here I will create a file called service.yml. Again, it could be of any name, but the extension could be YML or YML. Again, if you want to take help for the service, so you can go ahead and here type Kubernetes instead of deployment, just search for service YML and it will give you one example for it also. So you can go in here and it is giving a basic and very basic example of this one. Okay. So I will go to Visual Studio Code and I will start writing my service.yml file. The first line would be API version, and the API version for service is only just v1. Okay, so just v1. Now, what is the type that you are going to create? So, I want to create service. Next one is metadata, and in metadata, I want to just give a name. And name is we are going to give as app service. Okay, the next one is spec. Now, in the spec, we are going to select that this service is going to use which of the pods or which of the selected pod. So in here I will use selector. Now unlike your deployment inside the service, the selector need just key value pair. It will not going to take match labels. I will use app and the selector is second hyphen app. Okay. So if I'll go here, so second app. Once the selector is done, I need to go to the same indentation at this selector level and I need to specify the type of I want to use. The by default is cluster IP, but you will be able to access it within the cluster. The another one is node pod that we can use it later. The third one is load balancer that we are going to use so that we can access our application externally. Once you define your type, you need to define pods. The first one is you are going to define is protocol. The by default protocol is TCP, so I will mention as TCP. Now I am again here providing a list here because you can have multiple ports and configuration assigned to a single service. Okay, so that's why I am starting a single list. Now within this port, I will have port on which I want to expose it. So I will let's take it as 80 and then I will use a target port. Now this target port will be the port that on which the app is running inside the container. So in our app we have mentioned as 8080. Alright, I will save it and I will go ahead and I will apply the configuration file. kubectl apply -f service.yml. Okay, and look like metadata name is bad because it might take a service or it is not allowing anything. So let's change our name. Let's not give this because I think it is already taken by Kubernetes with some name. Let's give another name like appnet. Okay, and let's try to apply it again. And now it was created and our service is up and running. I will also verify the deployment that it has done. So kubectl get service. So it has created my service, which is of type load balancer. Now we need to also attach our service to the minikube, means we should expose it so that we can access it, right? So I will use minikube service and then my service name that is appnet. I will hit enter and within second of time it will open and it will open in our browser. Now you can see our app is deployed with declarative method also. For now I will cancel it and I will move ahead. So now we have created our deployment and we have created our services using declarative way or YML. Now let's move ahead and let's see how updation deletion works in declarative way. So if you will talk about updation and deletion of any service or scaling up, it is very easy. So for that, what you need to do in your configuration file, you just need to update. So if you want to assign it to replicas 2 and you just save it, just go through your terminal and just hit kubectl apply this one, and it will this time not tell you created, it will tell you configured. Now if you want to verify the deployments, so you can also verify. So I will use kubectl get deployments. So now you can see we have two deployments in hand. Again, I can go back and I can change it to one. I will save it, and in here I will just go to terminal, and if I will hit this one and if I will hit deployment, so you can see we have only one available and one might be in the terminating state. Okay, all the logs, all the things that you want to see, you can go to your minikube dashboard in the pods event section and you will be able to see whatever the changes you are doing here, you will be able to see as the events in the minikube dashboard. All right. Again, if you want to, so this is one was for the scaling. If you want to change the image, you can definitely change it. So just go ahead and use this one. I will save it. Right. I have changed this to V1, which I have already pushed to Docker Hub. You should be ensure that whatever image you are specifying here, it should be on Docker Hub. So I will save here and I will again go here and I will type kubectl apply ef deployment and it's configured. Okay, if I will check kubectl get deployment, so you can see it's available. It using the same pods. If I will use minikube service appnet, so it will start my browser, and in the V2 there was two exclamation mark, but in the V1 there is no exclamation mark. It means it has picked our image. So that's how it is easier for us to make these things using declarative way. We just need to change our configuration file and you just need to apply it. All right. I'm hoping you have understood. Now let's move ahead. Till now, we were creating a different file. Suppose if you have volumes also, you will be creating persistent volume or persistent volume claim later or an individual file. We will come to persistent volume and persistent volume claim in the upcoming chapter. For now, let's suppose if you have bunch of YML file, but you want to keep track of it and if you want to combine them in a single file. So how you can achieve that? Well, YML provides the feature for it. Instead of doing all these things here, what I will do, I will create another file. Let's give it the name as master.yml. Now I will go to the deployment file. I will copy all these things here. I will copy it. I will go to master.yml. I will paste it. And within the same YML file, what you can do, you can provide three hyphen, not four, not two, not one, exact three hyphen, because three means it is going to mention another YML file in the same file. And I will copy the contents of my service. So I will take this, I will copy it, and I will go to the master and I will paste it. Again, if you have persistent volume YML file, you can go ahead and type three hyphens and define next. You have more, then you can go ahead and type three hyphen and define next. All right, I will save it, and before applying this master file, I will delete all my deployments. We will be applying our master file from this page. To verify whether it was created using our master file, we need to delete our deployments, right? To delete our deployments, we can write kubectl delete deployment and then the deployment name, right? Just like we do as the imperative command. But we will not do that. Instead of that, what we can do, we can type kubectl delete -f, then deployment.yml. Now it is not going to delete this file. It is going to delete the configuration or the API that is triggering this one, which is deployment, and it will delete the deployment. So once if I will hit enter, now you can see the deployment.app, which was named K8's app, was deleted. Similarly, I can specify service.yml, and now you can see my service is also deleted. If I will verify kubectl get deployments, so I have no deployments, and if I will type kubectl get service, so I have no service. It's a by default service created by Kubernetes, right? Now we are ready and we are good to apply our master YML file that contains deployment and service together. So let's go ahead and let's apply kubectl apply -f master.yml. I will hit enter and it will give you that deployment, this one created and service also created. If I will type kubectl get deployments, so I have this one. If I will type kubectl get service, so I have also service in place, right? So that's how you can combine your multiple configuration file in a single file so that it will be easier to track it. Now let's talk about one more important aspect in your deployment, that is called liveness probe. Now what is liveness probe? So this is the feature of Kubernetes that provides a kind of a tool which is used to determine whether a container within a pod is still healthy and functioning properly. For Leibniz probe checks if the application inside the container is not healthy, so what it will do, it will cause a restart or it will stop that pod and it will cause a restart to it. So that's what the Leibniz probe is used for. Now the Leibniz probe is supported with various options. In this case, in our app, as it's a web application, the static web application, so we can define something called a get request so that it will check for a particular event of time. So let's use that. I will go to my deployment file here, and within the container at the image, after the image, I can use liveness probe. Then in here, as our is a web service, so it has a module called http get. Then I will define a path. The path would be a default, means our home page of our application, and the port on which it is listening to, which is 8080, right? Now at the same level of http get, this one, I will define period second, which is 10, means within 10 second of interval of time, keep checking for my application. And also I will use initial delay seconds. So let's give the initial delay second as 5 seconds so that we can be wait for 5 seconds before starting the testing. Okay. Also, as it is our web application, so I am using a http get response. Suppose if you have another application, like suppose if you want to check for any log whether it persists in a folder or not, so what you can use, I will write here for a dummy, so you can here write exec after your Leibniz probe, and you can execute command. And we are, as we are going to use multiple commands, so I will use list, so I will use cat, and then it will check for whether temp.logs is empty or not. Okay, and then you can verify your other things like your delay in seconds and whatever things. So in here what it will do, let's understand this. So as I have my application as an web application, so it will check, it is checking for http get response. I can also use this one. Now suppose if you have a logging system in place, so what it will do, it will keep checking for this particular folder inside your application, inside your node or a worker VM for every 5-10 seconds. If there is no logs, if this directory is empty, it will give you a non-zero value, means 1. It will trigger a signal to Leibniz probe that hey, you should stop it and restart your container. Suppose if it has found something, so it will return a code of 0 and it will not do any cause or it will not cause any restart. But if it is giving any non-zero or if it is not found this item inside this logs folder, it will stop the container and it will cause a restart and it will self heal it, right? Similarly for our web application, so if it will keep checking for every 10 seconds, if there is no, if it is zero code, means if it is checking successfully at this path, then it's good. But suppose if it is not found, then it will try to stop the container and it will recreate it again or restart it again. So let's see that. I will click on save. I will go to the terminal and I will also start Minikube dashboard so that we can see it in real time. I will also open another window. I will go to downloads and I will go to Kate's directory, and in here I will apply my kubectl apply f master.yml, and it should be okay, it's unchanged. Okay, so looks like we have mentioned a wrong spelling, initial delay seconds. So if you want to take help for it, so you can define it Leibniz probe Kubernetes, and you can take a dummy example for from here itself also. Okay, so initial delay second is 5 and period second is 5. So you can see in here it is checking for a directory also. And let me apply it again. So it is saying unknown because unknown field http get. Okay, so looks like I have done something wrong. Also, if you want to check for your http, so this one is the path, and here you should, I have make a mistake again, which is http and capital G. I will save it and I will again apply it, and now we can see it has configured. Now in here I will go to my Minikube dashboard and I will go to my pods, and its terminating state I will leave it, and I will go to this one state and I will go to the events. It has this one and I have only one. What I will do, I will use, and I will in here trigger Minikube service appnet. So now it will start in my browser. So let's wait for it. So I have this browser. Now what I will do, I will in here go and go to an error to crash my page, and I will wait for 10 seconds. So now it is thrown an error. I will wait for 10 seconds so that my Levinus probe will trigger. So now we can see that my Levinus probe is now working, and now after 10 seconds it should create, and now after some second, I think it took a minute around, but after it my Levinus probe was triggered and it gave my app fully functional up and running. Okay, so that's how the Leibniz probe works under the hood. So I will close all the tabs and I will move ahead. Also, for now, I will delete my deployments, and my deployments from one file itself, my deployment and service was deleted. Okay, so I'm hoping you have gone through the declarative way, and moving forward, we will be using this same way of creating our objects. So let's move ahead to chapter 6, in which we will talk about how we can manage data and volumes with Kubernetes. Till then, take care. Hey guys, and welcome to chapter 6. In this chapter, we will see how you can manage data inside your containers to pods or nodes, and also we will see some famous types of volume in Kubernetes. Okay, so with it, let's move. Now, let's first understand what is Kubernetes volume. So, we have seen volumes in Docker also. If you haven't gone through Docker, I would request you to first go to the Docker course first on my YouTube playlist. I have provided the link in my description. Please go through it first and then come to the Kubernetes. Also, before this chapter, we have 5 chapter that you should cover first before moving this one. Similar like your Docker volume, Kubernetes also provides a way for containers in a pod or in a node to access and share data via the file system. Now, whether this data sharing can be between the containers or can be between the pods. Now, these can be in between the containers, between pods, or even from your cluster to the containers. There are various type of volume supported with Kubernetes, and there are different purpose for using Kubernetes. For example, if you want to populate a configuration file, so you can populate with the help of config map. We will talk about each of these famous volume types in the upcoming slides. Also, there is one more configuration file related that is called secret, in which you can store sensitive data like password and other things. The another purpose is it will provide a temporary space for your pod, so it will be very helpful for a logging or for a event gathering system. If you want to share a file system between the containers or even between the pods, or if you want to get a data persistent mechanism within your cluster, even if the pods or container restarted, then also Kubernetes volume has one of the types for this purpose. So for each of these, we have different purposes, and it is not limited with these purposes itself. There are 50 plus ways and 50 plus purposes in which you can use your Kubernetes volume. With it, let's move ahead and let's see what we are going to cover in this chapter. We are going to cover in this chapter first the Kubernetes simple volumes. The first one is empty dir and then the host path. Then we will move ahead and we will learn about how you can manage environment variable and the password like information in secret, right, with the help of config map and secret. Then you will learn something called persistent volume. As the name suggests, it will persist even if your container or your pod is getting failed or even if it is getting restarted. So for that we have two terms, persistent volume and persistent volume claim. We are going to cover both theoretically and practically illustration for all of these types. Now, the Kubernetes volume is not limited to only this type. For example, we have one more famous that is called CSI, which can integrate with your cloud and provide more functionality to it. There is another one that is called NFS, Network File System, in which you can use your file system instead of host path. Okay, so the syntax will be more like the same. Again, if you want to learn more about them, you can navigate to Kubernetes docs. So in the official doc of Kubernetes, you can navigate and learn about all of these things that we have discussed so far. What are their types, how they work under the hood, and what are the types that they are supported. Also, there are various type of volume that they currently support using cloud technologies also. Now, for example, this AWS Elastic Block Store. So this functionality was like it was using CSI driver to host and connect your data directly from your container to AWS backend. Similar that was Azure and it is now deprecated. Now all these type of Azure disk that was used earlier as a legacy, now it was redirected to the CSI. Basically, CSI is Container Storage Interface. It defines a standard interface to expose storage system to containers using your cloud provider technology. There are some types, those are deprecated and those currently using CSI driver, and the main that we are going to discuss, those are currently active. So we'll discuss about these most famous Kubernetes volume. within examples. Okay, but still, if you want to explore more about it, for example, FC fiber channel, so you can go ahead, you can take an example, you can have one example of it, you can see what it is using. So again, if you want to find more details and help about any Kubernetes volume, then you can navigate to Kubernetes documentation section. Because suppose if I am explaining MTDIR and if I am giving you an option that is deprecated when you are trying to practice them, then for that, instead of rounding on the web, you may directly go to Kubernetes section and you can see that whether that option is currently supported or not. Okay. So with it, let's understand why do you need volumes. In general, you have a node that is running in your cluster, right? Now within your node, you might have one or two pods running inside it, correct? Within these pods, you have two containers. Now by default, if a container is lost, your data is also lost, correct? So with it, you can have three definition of volume, three concept of volume or three types of volume for now you need to understand or how you can create it. The first one, you can directly create a volume inside your pod. Okay, inside your pod that will connect your container to the pods. What will happen whenever your container will crash or it will restart, it will keep your data inside that pod. The second case is, what if even your pods are also failed? So for that we have different kind of volume. With that, what you can do, you can use your node's local file system to mount the storage or volume from your node to the pods. So suppose if the pod crashes, so the volume is still inside your node. The third type is, suppose if your node is also failed and it causing a restart. So how you can check? So for that, you can deploy a volume type inside your cluster, and then you can directly map from this local file system to the node or even inside your pods, right? So they are directly mounted to the pods. If the node crashes, then the data is also persist. So these are the three types or the three ways you can define the need of the volumes. So I'm hoping you've understood. Let me know if you get any doubt. I will try to reply in the comment section. With it, let's understand what are the differences between K8's volume and Docker volumes, because whatever app you will deploy, you can create a Docker file, you can build your image, and you can still use your volumes, Docker volumes, right? If you are aware of Docker volumes, so you know that you can use it, right? If I will talk about Kubernetes volume first, so they support many drivers, even the cloud also, and there are many types supported with Kubernetes. Now, in Kubernetes, the volume may not necessarily persistent as you are not managing containers directly. But in Docker, we are managing our containers directly. What do I mean by that? So we are creating pods, we are creating deployment, we are not creating containers, correct? Although we can navigate to containers, inside the containers, we can mount it externally. That is the advanced topic that we will not go right now. But in here, you are not managing containers directly. In Docker, there are no drivers or types supported. You have just two types of volume, like your named volume, or the second one is bind mounts, in which your local file system is also exposed, right? The second one, the second reason of Docker volume is the volume persists until, sorry about that, it will be manually created because we are managing containers directly, right? So in here we are working with the containers, but here we are working with orchestration. Now in both of them, volume survives on container restart or crashes. So if any container crashes or restart, the volume will survive based on what the volume type or driver you have selected. Okay, so I'm hoping you have clear about the basic Kubernetes volume concept. Now let's move ahead and let's understand about the first type of Kubernetes volume, that is empty dir. Now, as the name suggests, it's a empty directory, it's an empty volume that will be created when your pod will be created, and it will be inside your pod. Whenever you will need to define that your container is mounted to this volume. The Kubernetes is not going to automatically mount to this one. So for that we have option called volume mounts. Okay. Now it creates an empty directory when the pod start, as I said. It exists as long as the pod runs. So whenever if you will kill the container, if you will restart the container, there is no dependency of volume on this. It will persist. But when you will kill the pod, so this volume will be also killed. You can use this for sharing data between containers. If you have two containers in here, so what it will do, it will mount the same volume to these two different container. Or suppose if you have different pods, so you can use this volume to map it to the different pods also. Correct? Now let's understand its illustration. So for that, I will move to my Ubuntu VM. I am on my Ubuntu VM and I will create configuration file for explaining mtdir demo. Now before that, I would like to explain what I am going to do. So as I said, the mtdir can communicate between two containers within a single pod or even if it can be used from one pod to another pod. But in this illustration, we are going to take two containers in the same pod and we are going to mount our empty dir volume to both of them container. We will write in one container and then we will be able to see the difference of whatever the contents we have written inside the another container. Okay, so I will go to my Visual Studio Code and I will close all the tabs here that is opened. In here I will create a directory. I will create a directory and I will call it as K8's volumes. And in this K8's volumes, I will create a file called empty dir.yml. Okay. Now in here, the first line would be my API version and this would be V1. Again, if you want to see the details or the help about any of them, you can navigate to the references section of Kubernetes official docs and you will find the examples. Now in here, instead of deployments, I'm going to create a pod. So kind would be pod. Then the next mandatory field is metadata. In the metadata, we can specify name or labels, but let's go with empty dir demo, right? Now in here, the next one mandatory field is spec. And in here, we are going to create containers and we are going to create two containers. The first container would be name as, let's take the name as writer. I will use the image as busybox. So busybox is basically a very basic image and it contains a very lightweight Linux file system. Now within it, I will use a command. So whenever it will create this container, so it will trigger this command. The command that I'm going to use, so it will called, so I will use C shell and I will write to it. I will use echo hello from writer container. Now what I am trying to do here, in here I am trying to write. So what this container will do, this container will write this thing hello from write container to, let's give data message. Okay, and also let's give sleep 3600 so that it will, if it will takes time in creating, so it should not crash. This is my first container. The second container would be reader. I would use the same image name, busybox. In here, I would need to read from this container. So let's take all of these things from the same. So I will just copy them and I will paste here. And instead of echo, this one I will use cat. Okay, so cat data message. That's it. Now I have created two containers. Now I need to create volumes also. The volumes that you will create inside this spec in the parallel of this container. So with at this indentation at containers level, I will create volumes. Now the volume that I will create, I can create multiple volume, but for now as I am illustrating empty dir, so let's give the name as shared data as the volume name. And what is the type that you are going to create? So I will create the type as empty dir, and we just need to specify this or this. Okay. Now again, there are various options supported with this empty dir, but for now I will go with the basics. Now once you have defined your volumes, you also need to attach to your containers. You cannot just specify and you ensure that Kubernetes will automatically attach this volume for you. No, they will not. It will create the containers, it will create the volumes and these containers inside the pod. But you need to connect your volume to this container. So for connecting it, what you can do, you can use a keyword called volume mounts. Okay. Now here you need to specify what is the location from which you want to mount to. So I want to mount it to mount path. The mount path would be data inside the container and then the name of the volume that you want to use here. So the name is shared data. Now this similar mount I need to provide here. So with it, my configuration is ready and I am ready to run it. So let's save it and let's try to run it. I will go to my terminal and I will navigate to its volume folder. If I will list, so I have my empty dir yml file ready. For applying it, we have kubectl apply -f and then my file name. Okay, so I will hit enter and looks like I have wrong thing in here. So let's see. Okay, so looks like I have done some mistake. It will be not empty dir, it will be empty capital dir. I will save it and let's try to deploy it again. Now it is telling that my empty dir demo was created. Okay, so now I have my pod running. So let's verify that kubectl get pods. I have my pods running. So it's currently creating. So let's wait for my two containers to create. Okay, now within second of time, we have both of our containers running. There is one more thing that I would like you to show you. We have given the commands here to write the stuff to any particular directory and also to read the contents from any particular directory. Whenever the container was created, so it was ran inside the container. You won't be able to see it here. So how you can see it, how you can manipulate and connect and try to run command inside your container. In the Docker, we have Docker exec command. Similarly, in Kubernetes, we have also kubectl exec command. To run commands inside your container, you have kubectl exec -it interactive terminal, then your pod name. The pod name is empty dir demo, and then you will have your container name. So container name, let's take reader because we want to read content from our reader one. And then I will use -. What is the command that you want? What is the cell you want to use? I want to use bash. Okay, so looks like our bin bash is incorrect. Now instead of bin bash, we will use bin sh because in busybox we don't have bash installed by default. So I will hit enter and now inside my container. So if I will type host name, so I have empty dir demo. So it will be telling the pod name as a host name, but it's running two containers inside it. Now in here, if I will list the files, so I have these things, right? So let's go to data. And if I will list, so I have message, right? So let's read this cat message. So you can see we have hello from write containers here. But what in which container we are in? So we are reader container. So that's how you can communicate using your empty dir using two containers. So with the help of empty dir, we have tried to mount our empty dir volume to two containers, and we have written the contents from writer container, and we have tried to read it from inside our reader container. Again, if you will try to delete anything, if you will try to delete this one, and if you want to keep this one, so there is no way it will get lost. So the volume is stored in this one. But if you will try to crash this pod, if you will stop this pod, if you will try to kill it, then the volume, that the content that is stored by empty volume, that will be deleted, right? So that was the example of empty dir. I am hoping you are clear. Now let's move ahead. Before moving ahead, I will try to delete the containers. So kubectl delete hyphen f, and the file name is empty_dir.yml. It will not delete the file, it will delete my pods, and it will delete my containers, and it will also delete the volume that we have mentioned here. So it will get deleted in the background. Now let's understand the second type of Kubernetes normal volume, that is called host path. Unlike your empty dir, so what the empty dir was doing? The empty dir was doing, suppose if your container crashes, so it will keep your data inside your pod and it will keep persist, right? But suppose if the pod is also failed, so the data of yours will get lost. So for that we have host path, in which it will create a volume, it will mount your node file system to your pods or to your containers. So even a pod restart or fails, so it will keep your data, but you should be very careful while using it because you are exposing your node's local environment to the pods. So it is the host path volume type is not recommended in production environment. So I'm hoping you have got some understanding about host path. Now let's move to our VM and let's see the illustration of host path also. I will clear my terminal. I will go here, and in here I will create a file called hostpath.yml so that I can write some files. Now these similar like your Docker bind mounts, in which you bind your local PC file system to the Docker container. But in here you will not mount your local PC. You are going to mount your node local file system to the containers or to the pods. Okay. To illustrate you, to give you an example, what I will do, I will create a host path and I will take this and I will mount it to my nodes file structure called var log. It will be inside my var log. Okay. Inside my node local path. And now on that volume I will try to mount it to my container or my pod. Then I will try to crash that pod or a container, and then I will again try to check whether my data is still there or not. Okay, so with it, let's move ahead. I will give API version, and again I will give API version as v1, and I'm not going to create deployment. I will create pod itself. Then I will give a metadata. And yes, you are right. In metadata, I will give name, and name I will give host path example. Then in here, I will give spec, the fourth mandatory field, right? Then after indentation, I will give containers. I'm not going to use to container because it is not use of host path. The host path is like checking your container is persisting your data even if your pod crashes or not. Correct? So let's go ahead and let's use container and let's create our first container. Let's create our container. Let's give the name as container one. I will again use my image. I will use again image, basic image, bg box. Now after image, what I will do, I will use a command, and then I will try to use my sh. So let's use sh. then hyphen c, then echo hello from host path, right? And I want to write it to, let's take that same folder inside our busybox container, which is data and then our message, right? And I will stop this one and let's take the sleep also as some seconds. Okay. Now once it's done, I will come to the volume section. Okay, at the same indentation at containers, and I will use volumes, and I will use name host wall, then I will use host path. Then what is the part that you want to mount from your node local file system to the container? So from my node local file system, I want to use temp and host data. Now you need to make sure that this should persist. If it is not inside your node local file system, then inside the type, you can specify directory. If this directory is not there, then you need to specify or create. So it will check whether this directory is exist. If it exists, then it's good. If it does not, then it will try to create it. Now we have created volumes, we have created containers, but we need to attach our volume to the container, right? So for that, what we can do, we can use volume mounts. Then the name of my mount, the name of the mount is host wall, right? This one. And then what is the mount path that you want to mount from this one inside to this container? To this, we can mount just a data folder inside our BGBox container. So it will mount this folder from my node local file system to this folder inside container. Okay, so I will save it and I will go to the terminal and I will apply it. So kubectl apply hyphen f and then host path.yml. I will hit enter. The pod was created. I will verify the pod kubectl get pods. So now you can see my pod is running. Again, I have written something inside my container, right? This I have written from inside my container and it was stored at data message, right? So I am mounting my whole data folder and it will be mounted to my this location inside my node local file system, correct? Now what I will do, I will try to delete this container. I will not specify volumes. I will not try to delete this volume because I want to check the persistence. So let's try to delete this container. So kubectl get pods. I have these pods running. Let's try to delete this pod. So kubectl delete pod and then my pod name. So which is host path example. Okay, I will hit enter. Now it will delete my pod. If I will run kubectl delete hyphen f, then it will delete our volumes also. But we don't want to delete our volume. I want to keep it so that I can check whether it is persisting my deletion on a pod or not. So I am deleting my pod. So let's wait for the pod to delete. Now once my pod is delete, so what I can do in here, I can use another container with the busy box and I will use the same volume here and I will not give this command here. Let's give only echo hello here so that it will get something and it will keep this container up and running. And now we are mounting our volume that was still earlier to our new container. So let's go ahead and let's try to use this one. Before that, I will save it and let's try to apply it again. So kubectl apply f host path.yml. Okay, so looks like my something is different, so invalid. Volume mount path is required value. Okay, so we have removed mount path by mistake. Let's take again. Let's mount it to the same folder. Okay, so let's go ahead and let's try to apply it again. My pod was created. Now let's verify my pod kubectl get pods. So now it's up and running, correct? Now let's try to go inside the container and let's see whether it has mounted our data from earlier container to this container or not. So in here, I will go here and I will write kubectl exec interactive terminal and then my pod name. The pod name is host path example. Then I will specify -c for container name and the container name that I have given is container 2, right? So this one container 2 and I have given wrong spelling container 2 and I will use bin sh. Okay, I will hit enter. I am inside my container that was created. Now if I will list, so I have these things. I will navigate to the data folder and if I will list the content, so you can see I have my message. You can see I didn't create any message here, right, in the container 2. Earlier we tried to mount from my container 1 to my volume, then I deleted my pod, right? I deleted my pod. Then I tried to create one more pod with another container and then I tried to mount the same volume. And you can see, so this one is just a echo message, it's not writing anywhere. And in here you can see my message from my earlier container is there. If I will type cat message, so I have hello from host path that was from container 1. That's how the host path works. I am hoping you are clear. Let's move ahead. I will exit from it and I will also delete my deployment. So kubectl delete -f hostpath.yml. I am hoping you are clear with the host path concept also. Let's move ahead and let's understand about config map. Now the config map and the secret, basically they creates a key value pair. They uses a key value pair and they store in etcd inside your cluster. They are not dependent on your node, pods or anywhere else. Now what's the use of it? So inside of using environment variable directly inside your code, you can directly mention the key from the etcd config map and it will fetch the value of that key automatically in the background. So basically it survives the container, pod and even a node crash. So let's understand, let's use any environment variable to use this config map. So I am on my VM in which the Kubernetes and Minikube is running. I will create another file and I will give it as config map.yml. Now to create a config map, we can create it via imperative command. And how you can use imperative command? So you can type kubectl create config map, then your config map name. Let's suppose you are giving the name as config hyphen map. Then you need to specify hyphen hyphen from literal equal to what is the key of your environment variable. Suppose you are giving the key name as app underscore mode and then what is the value that you want to assign it to this environment variable. So let's see, you want to assign production. Similarly, if you want another environment variable to be defined, so you can type hyphen hyphen from literal and then the same stuff. But I will not do with imperative command. I will do it with my declarative method using YML file. Now, either I can create a different config file or I can combine it and I can write two configuration file in the same YML that we have discussed earlier, right? So for that, let's first write a config map file first. So I will use API version, and the API version is v1. Then the kind will be config map. Then I will give metadata, and the name of this config map that I want to give is app config. Now once it's done, you need to specify something called a data for this kind of set. Unlike your pods or Kubernetes, which needs spec as a mandatory field, the config map needs data. Similarly, the secret that we are going to learn in the upcoming section. So the secret is also having some mandatory field that is data. Okay, they don't require any spec or anything like that. Now in here, what you can mention, you can specify your key and value pair. So app underscore mode, and you can see that all the environment variable are in capital letter, so you need to make sure that. And then I will use production. Then the next one is, let's take a log level, and the log level I would like to take as debug. And then let's give one more, that is database underscore URL, and let's give the database URL as xyz.com.com/admin. All right, then I will save it. After this, I will do a 3 hyphen so that my new config file that I can start here. And with here, I will start my main file for my pods. Okay, so let's give that. The first line would be API version, that is v1. Then I will give the kind, and the kind I will give as pod. I'm not going to give it as deployment. Then I will give a metadata. In the metadata, I will give name as config example. Then in here, the pod needs spec for sure. So I will give that, and I will specify containers. And inside it, I will give the container name. The container name is, let's give the container name as my app. Then in here, I will give the image, and image will be, let's take busybox again. Then I will specify command argument, and we'll do the same thing like sh. We want to use C shell hyphen c. And then what I will do in here, I will type echo, and then within it, I will take, and I will mode, and I will call my environment variable here. So app underscore mode. Now you can see we are not defining this app mode inside our pod. So we will take reference from our config map, and it will pass here, and then it will try to paste it, right? So let's take this echo mode app mode and echo db to database URL. Okay, I think we are good with that much. Now instead of echo, let's remove echo, and let's take this one, and db equal to database URL. Okay, now with it we can also specify. Now let's write this content of this container to data and message. Okay, I will close this one, and I will also use sleep 3600. Okay, so in here I am just recalling my environment variable, and I am just doing the echo, and I will write it to data message file. Now to use this app underscore mode, you need to specify env key, because that, if you are using dollar than this one, then it means it is environment key, and you need to specify inside the environment key. Now in here, you can definitely go ahead and type app underscore mod, and then you can define directly here, but we are not going to do that. We are going to take reference from the config map that is being stored in etcd keep here inside our direct cluster. So in here, let's take the environment name, and the environment name that is here that we are calling is app mode, right? This one. So it's taking from here, but this environment variable, how we can recall it? So the value we will take from, so I will specify value from. Now in here I will specify config map key ref, means I want to take the key. So I want to take the value of this key from my config map. So config map key ref, and here I want to take the name. The name of this config map would be app config, app config. So this one, right? And then what is the key that you want to take? The key I want to take is app underscore mode. So what it will do, it will take this app underscore mode, this one, and it will pass it to this environment variable, and then after it, this environment variable will pass to here, okay, whatever the value inside here. Now similarly, as we used another environment variable called database, so I will copy this same and I will hit enter, and this one is database URL, and here it's also database URL. Okay, I will save it. Now I will go back to my terminal. I will list here. So I have my config map.yml. Let's try to apply it. So kubectl apply hyphen f config map.yml. Now the config map was created, but looks like we got some error in config map example, because looks like the name that we have assigned, it's not allowed, that my app. So let's go ahead and let's minimize it to my app. Okay, I will save it and I will again go back and I will again apply it. Now we can see the config map was created and also our pod was created. Now if I will verify the status of my pod, so kubectl get pods. So my config map example pod is up and running fine. So what I can do, I will go inside the container that was created in this pod. So let's go ahead. Kubectl exec hyphen it. Then my the pod name is config example, right? Then hyphen c for specifying my container name, and the container name that I am going to use is my app. So I will specify my app. Then what is the cell type that you want to initialize? So I will specify bin sh. I will go ahead here. If I will list, so I have bunch of things here. I have routed. So if I will go inside here, so it has written in data and message. So let's check this one. Okay, so looks like it didn't create data and the stuff. So first let's create it. I will create a file or folder. So let's create it. So in here I will use touch. Now in here I am creating a file called temp hello.txt, and I will also use the same path in here itself. Okay, I will save it and let's try to use that one now. I will exit from the container and I will first delete it. Kubectl delete hyphen f config dot yml. So let's wait for it to get deleted and then we will reapply it again. Now once it's deleted, I will apply it again. So now it was created. I will verify the pod kubectl get pods, and now it's running. Let's try to re-enter in my container again. Kubectl exec it, then my pod name, then hyphen c because I want to go inside my container, then the container name. And what is the cell type that you want to enter? So I want to use bin c shell. Okay. So I will hit enter. So if I will list the files, so I have bunch of folders. Let's go inside temp. If I will list, so I have my hello.txt. If I will If I will try to read the contents of hello.txt, so you can see it is giving mode production and db equal to xychat forward slash admin. Now, how it did work? So this environment variable that it is taking in my code, so it is taking from this env key. Okay, so here it is. Now here you can directly define your value here, but we are not using that one because we want to keep our app secure. So for that, we are specifying a config map, and then we are passing a config map keyref, so that we are using the app mode key directly from our config map. So without exposing this to our production environment, we are using the value of environments. Okay, so that was the use of config map. So I will move ahead. Now before moving ahead, I will try to exit from the container, and I will also delete my deployments. I will move ahead and let's explore about secret. So similar like your config map that was storing your key value pairs in the etcd directly inside your cluster, so that if the node fails or the pod fails or the container fails, so it will keep your data inside your etcd pair. Similarly, there is a secret in which you can store your sensitive information like password or key or credential just inside your etcd. So we can use it as a environment variable, or even as a mounted files, even as a volume, or even we can pull private registry images using our docker registry credential defined inside our secret. Okay, so we can define our docker credential in our secret config file, and then we can use it inside our deployment. So let's see how we can achieve this. I will clear my terminal in here and I will go to my Visual Studio Code. Now inside here I will create a file, and let's give the file name as secret.yml. Now again, if you want to create using imperative way, you can definitely do that again. Kubectl, then create secret, then generic. You need to provide a driver that is generic. There are various drivers supported for secret. If you want to learn about it, you can navigate to Kubernetes. For now, I will use generic. Then you need to define your name of your secret. So I will define my secret. And then here again, you need to specify hyphen hyphen from, then literal. Then what is the key that you want to specify? So let's say the username that I want to take as admin. Then again, you can specify from hyphen literal, and then you can specify password equal to your password. Now this password will be base 64 encoded. Okay, so you need to make sure that the password that you are providing here, it is base 64 encoded. If you want to change your password to base 64 encoded, you can go online and search for convert my password to base 64 and it will change it. Okay, for now I will cancel it and I will follow the declarative way. Now to create a secret, I will specify API version, and the API version that I want to use is v1 because it is supported currently. Then kind is secret, then metadata, and then I need to specify a name. The name that I want to take, let's take the name as my secret. Now here you need to specify a type that is a mandatory field of your secret, and that is opaque. Then in here you need to finally specify data. Now inside the data you need to specify what is the username. So let's give the admin, and you need to specify password. Now as I am showing you for demo purpose, so I will directly write my password. I will not encode it. But suppose in your code, if it is authenticating in your Docker registry key, okay, so how you can pass the username and password? So for that, you can specify the username and password here for the Docker registry key. And whenever your app will try to config or will try to fetch the private registry, so using this secret, it will automatically authenticate it. Okay. Now I will provide three hyphens so that I can start my pod configuration from the same file. In this demo, I will use my secret as a volume mount. So I will start API version, and the API version for my pod is v1. Then the kind, I don't want to create deployment, I will create a pod itself. Then metadata, and the metadata that I want to take as name. So the name, let's take as secret demo. Then as it's a pod, so I need to specify a spec. Inside a spec, I need to specify containers. Within the container, yes, you are right, I need to specify a name. The name will be demo. Then I need to check the image. The image name I would like to take as bgbox itself. Then I need to take a command. The command that I want to take here, 3600, so that my container is wake up till this time. Then I need to specify a volume mounts. But before mentioning volume mount, you should have a volume itself, right? So with the same indentation level of my container, I will specify volumes, right? Then what is the name of your volume? The name of my volume is secret vol, and then I need to specify secret. Now what is the secret? What is the name of the secret? So I need to specify a secret name, and the secret name that I want to take here is this one, my secret. Okay, so my secret. Now once it's done, I can specify in the volume mounts. So what is the volume that you want to mount here? So I want to mount here secret vol, right? This one. Then you need to mount the path here. So I need to specify mount path. Let's mount it to / temp /secret dot txt. And in here, instead of using this, let's use sh, then hyphen c. Then in here, let's use touch. Let's create this file, and then let's also use sleep 3600. Okay, as we don't want to write it from our containers in the production environment, you just need to mount, or you just need to access from secret key vault to your containers. You don't want to write it from your containers to the volumes, right? Because by default, the mount or the binding will read write allow to the both way, but we just want to read only. So in here, I will specify read only equal to true. Okay. Now with it, our configuration is ready. I will go ahead and I will try to apply it. So I will type kubectl apply hyphen f, then secret.yml cannot be handled as secret illegal base 64 data at input byte 5. So we haven't specified base 64. So we need to take something that is already base 64 encoded. Now to encode your value, what you can do, we can type echo hyphen n, and then we can specify, let's say admin, because my username was admin, and then base 64. So once if I will hit enter, this thing that it has given, it's a base 64. So I will take this one and I will copy it and I will provide it inside my username. Okay, similarly, I need to provide the password also. So I will copy it. I will go ahead here and then I need to provide my password. Now this is the password that is base 64 encoded. So I will copy it and I will go here and I will paste it. Okay, now I will save it, and now this one is my base 64 encoded, and you should not mention the direct values here. Now I will go to my terminal and I will apply it again. Kubectl apply f secret.yml. And now we can see my secret and my pod was also created. Now how I can verify that? So for that I will navigate to my secret.txt inside my container and will see whether I have my contents written here or not. Okay, because we have mounted our secret to this one. So let's see that. I will go here and I will type kubectl exec it and let me verify what is the pod name. The pod name is secret demo, and the container name that I have specified is just demo. So okay, so container name is not found. We haven't got this one. So let me verify whether our pods and containers are running or not. So it's still creating our container. So let's wait for it. Okay, now it is running. My container is up and running and it took much time. Not sure why. Now let's try to go inside the container and let's try to verify. So for verify that, I will go to my temp directory, right? So let's go to temp directory. Then I have my secret.txt. So let's see the content of secret.txt. Let's go inside this secret.txt. So if I will list the content, so I have my username and password in here. Okay. So if I will see cat username, so I have admin, and if I will type cat password, so I have admin at the rate 123. So the base encoded thing are again converting to the normal letters, means our normal format, and they are showing you inside the container while we have used our secret as a volume. Again, you can use secret as an environment variable also. So that is the illustration of secret here. Now let's move ahead and let's understand the persistent volume in Kubernetes. Now again, before moving ahead, I will exit from the container and I will delete my deployments. So kubectl delete -f secret.yml. Now it will delete my pod and my secret. So I'm hoping you are clear with secret. You can use it as a environment variable or using your mounted file means volume that we have used in this illustration. And even you can specify your secret as a username and password to verify using your Docker registry or any private registry. Okay. Now let's move ahead and let's understand persistent volume and persistent volume claim. What are they? The persistent volume is like a volume that will be created inside your cluster, inside your main cluster that is running. And the persistent volume claim is like the volume that is attached to your pod. Now, what it will do, suppose if you are defining a persistent volume to a 5 GB of space, persistent volume claim will ask persistent volume that hey, I need some GB of space from your space. So that is kind of a requester from the main volume. Basically, if any nodes also crashes, so it will keep track of your data, it will keep your data and it is not going to lost. So that they are used for. So the persistent volume, a storage resource provisioned in the cluster like a piece of disk or NFS share. It's managed by cluster admin or dynamic storage class. While the persistent volume claim, PCs are basically a request for storage made by the user or pod. This one, it's like I need 5 GB of storage from whatever the quota that you have from the persistent volume. And Kubernetes binds it to a matching persistent volume from it automatically. So I'm hoping you are clear with it. It's the same like suppose the any computer shopkeeper has a 1 terabyte 5 pieces of 1 terabyte of HDD with them. Now you go to the store and you ask them that hey, I need 2 terabyte 1 terabyte of 2 hard disk space for my work. So you go and you purchase 2 terabyte of space from them, while the shopkeeper has 5 terabyte of space. So that's how the similar way the persistent volume and persistent volume claim works. So let's move on our PM and let's see this. I will clear the terminal and I will go inside here. Now the persistent volume are also of various type. Now if I will go to the official docs of persistent volume, you can see there are various type of persistent volume supported here. For example, CSI, the FC, host path, IC, SSCI, local or even a network file system. As we are using Minikube, which is a single node cluster, you are already aware, we will use host path as an illustration because the host path volume is for single node testing only and this will not work in multi-node cluster. So we will use host path type of persistent volume in here and we will use local volume here instead. So for that, what I will do, I will go here and I will create a file and let's give the name as persistent vol example.yml. And in here, before starting this our deployment file, I will first navigate to my node. I will access my node that is that is being running inside my cluster. So as we are using Minikube, so I will directly use Minikube SSH to navigate inside my Minikube node. So now I am inside my Minikube node. So this is my node that is running my pods or container. So I am as my in my home folder. So what I will do here, I will create a file sudo mkdir then mount data. So it was created. Now I will use sudo sh-c. I will use echo hello from PV storage. So what we are trying to do, we are trying to create a folder inside our node or inside our Minikube node, and then we will try to mount it using our persistent volume and persisting volume claim. So for that, we are just creating a demo file here. So hello from PB storage, and then we want to write it to mnt and data, and then let's give the name as index.html. So if I will hit enter, so it might have created. Now if I will verify the content, cat mnt then data then index.html. So it has my data, so we have verified that. Now we are going to use host path type of persistent volume which is attached to our local node file system to the pods or running containers. There are also various type of persistent volume supported other than this host path, which is cloud storage called AWS EBS or Azure Disk or even a network file system that we have shown earlier on the web. Now, as we have done, I will exit from the container here from my node VM that was created using my Minikube and I will go to my Visual Studio Code. So first I will create persistent volume, then I will create a persistent volume claim and then I will create a node. So I will keep giving the comment here. First creating persistent volume. Okay. Now I will give the API version. The API version would be V1. Then I will give the kind. The kind is persistent volume. Then I will give the metadata. The metadata I want to give the name as PV, just PV. Okay. Then let's give the labels also if we can use it later. And let's give the type as local. Now in the persistent volume also it needs a spec. So we will specify spec. The first spec you can provide is storage class name that we are going to use as manual. Then I need to define a capacity that it's going to use inside the node cluster, the maximum capacity that it can use. So I will use storage equal to 2 GBs. If you want to specify MB, then you can go ahead and type MB. Okay. Then I need to specify a access modes. And access mode that I want to use is read write once, because as it's a single node cluster, right? So just write it read or write once. If you have many node inside your cluster, you can use read write many. Okay. And then in here, I need to use host path because we are using host path type of persistent volume. And here I will use path. What path you are trying to mount? I want to mount as MNT and then data. And I need to put them in double quote. Now it's done for my persistent volume. Now I will create a persistent volume claim. So I will write it next, creating persistent volume claim. I will start my another configuration, that is my AP persistent volume claim. The first line would be API version, that is V1. Then I need to specify a kind. The kind is persistent volume claim. So you cannot directly use persistent volume inside your pod or inside your container. You need to use persistent volume claim as an intermediator. Okay. Now I need to specify a metadata, and the metadata that I want to use directly just a small name, that is PVC. Then after it, I need to specify a specification. Again, I need to specify a storage class name, and that is going to be a manual itself. Then I need to specify access modes. In this case, it's going to be read write once again. Then at the same indentation level of access mode, I need to define resources. Okay. And then what you want to request is for, so request what you want to request, so storage, and I want to storage for 1 GB. Now you have seen that in the persistent volume claim we haven't defined any reference to the persistent volume. So by default it works using your persistent volume itself. Okay. So once your persistent volume also done, I will start my pod creation. Finally creating my pod. Then I will start my third configuration file. I will give API version as v1, then kind as pod, then metadata. I need to give the name of this. So I will give as example pod, or let's give as PV example. Then after it, then after it, let's use spec. Now within this spec, we will first use volumes, and we will specify the volume as, let's take PV storage. And what is the volume that you want to take is, so I want to take it from the persistent volume claim. Okay. And it would be not be capital P, it will be small p. And then I need to specify what is the claim name. The claim name is PVC, because that what I have defined in here, right? Now once your persistent volume claim is done, you can go ahead and start your container. So I will specify containers here. The volume is done. And within the volume, you can see we haven't specified persistent volume. We have just specified persistent volume claim. Now within the container, I will go ahead and I will give the name as nginx. Then in here, I will again use nginx as an image, because what I want to do, I want to start a web server inside my nginx. I want to start a web server there, and then the index.html, that file that I created earlier, this one, I want to directly mount it to my nginx web server. Okay. So that it is not going to use my default index.html, it is going to take this one as the index.html. So let's use that. As you are using nginx, so you need to specify ports also. So I will specify container container pod. Inside container, the Nginx always start with on by default port 80, and then you can define the name. The name would be would be http hyphen server, and then inside your containers you need to specify volume mounts, right? You need to specify volume mounts, and within the volume mounts you need to specify a mount path. Now what is the mount path that you want to mount it inside this container? So if you remember, the default index.html page is at user here nginx and then at html. So inside this it will by default replace and paste my index.html file inside here. And the name of this volume mounts that I want to give here is PV, right? The name of the volume mount would be PV storage because that's what we have defined here. Now, once it done, I am done with my persistent volume. So this one was my persistent volume, then persistent volume claim, and then my pod. So all of this configuration I have written in the single YML file. I will save it and I will go to my terminal and I will apply this one. kubectl apply hyphen f, and what is the file name that we have given? We have given persistent. Okay, I have done the wrong spelling. So persistent vol example, no sure. So I will hit enter and now you can see my persistent volume claim, and my pod of Nginx was also created. Now you can also verify your persistent volume. So you can type kubectl get pv. So it can give you that this is the PV and the capacity is 2 GB. This is read write once. Whether it is bound or free. So yes, it is bound. If you want to see the details about your PVC, you can also do that. It's also bound. Okay. And if you want to check about our pods, whether it is running or not. So yeah, our Nginx pod is running. Now, what we can do, we can go inside this Nginx pod and then we can use curl to basically navigate to localhost 80 so that we can check whether our Nginx HTML page was replaced using our local node index.html file or not. Okay, so let's do that. I will go inside kubectl exec-it. Then I need to specify my pod. The pod is pv-example. Then I need to specify -c for my container name. And the container name that I have given in here, it's called Nginx. So I will give Nginx. Then I will use hyphen and I want to start. Now this Nginx container is based on bash. So I will use bin hyphen bash. Now I am inside my container of Nginx. I can do apt update so that I can install curl and then I can use that. Okay, now once it's done, I can use apt install curl. Okay, so I think curl was already there. Let's try to verify curl http localhost, and if you will not specify any port, so by default it is going to route it to port 80. So once we have checked our localhost, so it is hello from PV storage. Okay, so how we did here? So basically this hello.pv was taken, this was taken from our node of my cluster, right? Directly. So we have directly gone inside our minikube and then we tried to create a file hello from PV store that is called as index.html. And instead of using our by default index.html page provided by Nginx, we have directly tried to mount it to this one. So if you will navigate to the local host inside your this container, so it will give you hello from PV storage. So that's how you can use persistent volume and persistent volume claim. For now, I will exit from here and I will delete my deployments. So kubectl delete hyphen f, delete hyphen f, and it will delete my persistent volume claim, and my nginx pod. Whatever the space that it has occupied, it will also free up from my node. So that's it for the illustration of persistent volume claim, secret, empty dir, host path, and config map. Also, there are various type of more options supported in there. For now, I just went with some famous volume types and configuration type supported by Kubernetes. I will store these codes on my GitHub also, and I will provide the link of my GitHub in my description box so that you can take them as a reference and you can integrate and you can use them as a reference in your project or in your app. With it, we are done with chapter 6. Now let's move to our chapter 7, which is all about Kubernetes network and services. We have seen Kubernetes services earlier, but let's explore more about them. Hey everyone, and welcome to chapter 7. In this chapter, we will talk about what are the most popular type of networking, means how you can communicate between pods, between containers, and between node. We will try to discuss about an overview about them, and we will also see them in the practice while working with Nginx containers. Although we have seen Kubernetes networking in our previous chapter that we have discussed about services, in which we created something called load balancer type of service to expose our pod to our local machine. But that was only one type of networking that we have discussed so far. So let's discuss about more on Kubernetes network in this chapter. So there are various type of networking possible between container to container, between pod to pod, or even node to node. And in all of them, we have various options. Okay, so let's first discuss about the first possible networking that is possible in Kubernetes, that is container to container. Now, by default, the container to container networking or communication is enabled by default. But suppose if your one container is running another app and the another container in the same pod is running another app, then it's not going to take a route to a particular container if you are trying to access it from inside the pod. If you are navigating inside the pod and if you are trying to host localhost, so one container will run an app on port 8080 while the another container will act as a sidecar, and that can be accessed via localhost 8080. Okay, the working scenario is like containers in the same pod. In the backend, they share a same network space, including the same IP and the same port. They are not going to assign it with different IP or different ports, but there is a possible way in which you can export your particular container to the outside world and you can assign a specific port to access that particular container. Now we have discussed it. For all of this, we will discuss it in our demo that we will cover after covering these basic things to understand first. Now the second type is pod to pod network. So in here, this is the communication between different pods. Either they can be in the single node and either they can be in the different node. Now, if you want to try to connect to a different node, you need to set up overlay network. Also, every pod must have a unique IP in the cluster. And if you want to have a unique IP and a static IP, then you should use a service. Okay. Basically, this pod to pod networking, especially if you are talking about different nodes, they are achieved via CNI, Container Network Interface plugins. Example, Flanner, Calico, WaveNet, and Cilium. Basically, they are used for internal service communication between microservices. So if you have large type of microservices deploy and they are working as a node, you definitely need to make communication between those two nodes. So the pod to pod networking type comes into that scenario. The third type is pod to service. So in here we have discussed about various type of services, right? For now we have understand about cluster IP and also about load balancer, but there are also another type of service that is called node pod, in which you expose your particular node to any specific port outside the container or cluster. Okay. Now, the pod to service networking, in which the pod communicates using a stable, and if you are using the stable word, that means you are using a service instead of dynamic pod IP. The by default service type that is going to be assigned to a pod or a node is cluster IP, if you are not mentioning the type of cluster IP. How it is working in the background, the Kubernetes uses kubeproxy to forward traffic to the backend ports using these services. If you want to access them, you can just type curl http and then your service name and your port on which your application is running, and it will redirect to your application. The third type is pod to service networking. Basically, the scope of this type of networking is when pod communicates using a stable service IP, and the by default service IP, if you will talk, it's given by the cluster IP service instead of dynamic pod IP. So basically, dynamic pod IP are not stable. If your pod will be deleted or restarted, the IP is lost. So if you want to ensure that the IP should be persist, you need to make sure that you use service with your deployments. Now, the kubeproxy, the Kubernetes uses kubeproxy to forward traffic to the backend ports. And how you will expose or how you will access your application or service, you can, in your local environment, you can type http and then your service name. If you have exported your service to any external load balancer from your local host, then you can directly access it. They are generally used for your load balancing across pod replicas if you have multiple pods. Now, the next type is external to service networking, in which we have some bunch of type of services that we have discussed earlier also in some of them. The load balancer and the cluster IP, we have discussed it. The load balancer is basically creates an external load balancer that it is going to be bound to your local environment, to your pod or the container. The node port basically exposes a service on each node's IP at a static pod. Okay, so it's going to expose your pod to the outside world. Now for node port, you have three ports option that you need to specify. The first one is port in which your application is running. The second one is target port on where that on which port our service is going to attach to that particular node. And the third type is the node port. So that is the port that you will use to access your application. Now, this node port varies from 30,000 to 32,767. If you will not specify any node port, then Kubernetes will automatically assign any port in between 30,000 to 32,767. You might have also seen earlier when we were creating a load balancer service type. So whenever we were trying to expose our service to Minikube, like Minikube service our service name, so what it was doing, it was automatically giving the IP, and you might have remembered that the port was in the same range. So that's how it works. Now there is also another type, ingress. Basically, it routes a HTTP or HTTPS traffic based on your host path or rules. If your application supports an API or a path-based rules, then you can use ingress to route the traffic. Also, you can use a load balancer. Now, if you want to expose service on any pod, then you need to use node pod. If you want to just expose or access your app or pod, then you need to use the cluster IP, that is the default service if you will not specify any type. Okay. Now you are already aware of this use. It is used for allowing external clients or user to access apps in your Kubernetes. These external to service type of networking. Okay, so I'm hoping you have understood the basics. Now let's move ahead and let's understand what is our example scenario. So first we will have our minikube cluster, the same as we will be running. Then we can have two node, but as minikube have one node, so we don't need to worry about two nodes. So we won't be able to illustrate communication between node to node because it needs a overload network. So we can discuss it in the advanced course. Now we will discuss about one node because the minikube by default provides one node. Now in this node, we will create two pods. We will differently deploy them. And then in first pod, we will try to deploy two containers with name Nginx1 and Nginx2. And in the pod B, we will try to deploy a container called Nginx3 so that we can understand all the scenario between the container to container, then the pod to pod, then from one pod to another pod inside the same node. Okay. So let's discuss about all of this scenario while moving to on our Ubuntu VM on which our minikube is running. Hello and welcome back. I am on my Ubuntu VM. I will first verify the status of my minikube. So my minikube is status running. All these things are running. So I am ready to move ahead. If I want to check the deployments, so I need to check them. So kubectl get pods. So there are no pods running. There are no deployments running. I am good with it. I will clear my terminal and I will move to my VS Code. Now in here, the similar we have created for volumes, we have created a folder. So I will create another folder called K8's network. And within the folder, I will create first file and let's call it as pod a.yml. Okay, so we have created inside K8's network. Now this pod A will contain two Nginx container. Also, while creating the container, we will use a command option so that we can change our default index.html page that says hello from Nginx to hello from Nginx1 or Nginx2, whatever the container name that we will specify. Okay, so let's take this. So the first line would be you are already aware, the API version, and the API version would be v1. The second mandatory field is kind, that is pod. Then we need to specify metadata. In metadata, we need to specify a name of my deployment or this pod. So I will specify pod hyphen a. Now in here, I will also give a labels. And the label I would like to give is app equal to nginx. Okay. Then at the same indentation label of metadata, I will give spec and I don't want any volume. I just have containers. Now I need to give the name of the container. The first name of the container would be nginx1 and the image also I would like to give at nginx. Okay, if you want, you can take nginx alpine, that is the lighter image version of nginx. Then I will need to specify a port. So Nginx is like a web server. Inside the container, it will be running at the default port 80. So you can specify container port as 80. Now once the port is done, so at the same indentation level of ports, I need to specify command and I need to provide command to change my index.html page. First, I would need to give that I need to use C shell, then I will provide comma, then hyphen C, the same like that we did earlier. Then we need to specify echo and let's give hello from nginx1 container and I want to write it to the by default page of this one is user share nginx, then html, then index.html. Okay, so that is the default location of nginx homepage in your nginx container. Then I would use another command to turn off the daemon. I don't want it to get it run. So I will specify nginx -g daemon off, and then I need to close the command option. Okay. So in here, what I am doing, I have write a command. I am passing the command while creating my container that whenever it will go to and start our web server, it should replace the default index.html to this one so that we can identify whether it is a Nginx container 1 or container 2. All right. Now we are done with Nginx 1. Similarly, I will copy it and I will paste it for Nginx 2. And instead of Nginx 1, I need to specify Nginx 2. And in here also, I need to change my container name to Nginx 2. My pod A is complete and in which my pod A container is running in which I have two container Nginx 1 and Nginx 2 running. So I will save it and I will try to apply them. First need to, if I will list, so I have these one. I need to first navigate to my K8's network. If I will list, so I have pod a.yml. Now in here, I need to apply my deployment. So I will type kubectl apply -f, then pod a.yml. So looks like we have done something wrong and spec containers one ports duplicate port definition with spec container 0 ports pod a created. So it's giving us a warning that you are exposing the same port on the of these two different container. So it's given the warning, but it did created our container. So if I will type kubectl get pods. Okay, so one is crashing and one is ready. So let's verify the deployments and it given the error for one of my container. Okay, so looks like it's still getting error our pod and it's failing and due to self heal it's trying to our containers up again but is failing again and again, and looks like it is happening because on our pod it should not be the same pod on which two container is running. So let me change it and let me give it to 81 inside the container that we can change later. I will go to terminal and let's apply it again. Okay, so looks like permanent change field. So let's try to first delete it. Kubectl delete -f. Now let's wait for it to delete and then we will try to apply it again. Now once it's done, let's try to apply it again. So now our pod was created and there was no warning this time because we have specified a different pods. Now let's first verify kubectl get pods and all pods are up and running fine. So we are good. Now let's take the same image and let me create one more file and let's call this pod b.yml, and I'm just going to copy paste all these things till here, till first pod, and instead of nginx 1 I need to specify to nginx 3. Container port would be 80 fine. I need to change my container name to nginx 3 because it's a nginx 3, and then I need to specify the pod name as pod b. Okay, and the label would be fine app nginx because that is my overall app. I'm specifying the different pods for my app. So suppose if your app is combined with multiple services or multiple component that you want to create in different YML, then you can assign a labels. And within a few minutes, we will be also creating a services and how you will attach your services. So we will attach it using our labels. All right. So I will save it my podb.yml and I will also apply it. And the pod B was also created. I will check kubectl get pods and look like one of my pod A inside my container is again crashing. So we will check that later. Let's go with pod A and pod B. Now in here we have our pods ready and the containers ready. Now we need to create services one by one so that we can understand it. Okay. So if we need an static IP and a table IP for my pods or my container, so I need to create a service. The first service that I would like to create here would be the cluster IP. Okay, so let's give cluster hyphen IP dot YML. I am going to create a service type of cluster IP that is the default cluster IP itself. That is the default service that is provided by Kubernetes. So API version v1, then the kind would be service. Then I need to specify metadata and I need to provide the name and let's give the name at Nginx cluster IP Nginx cluster IP. Then I need to specify spec and within the spec I need to select what is the selector that I am going to use. The selector would be app Nginx. Okay, so that it will select all the pods that has label of app Nginx. Now once done, you need to specify a type. So I will specify a type of cluster IP. Now suppose that is not correct. That would be cluster and then capital IP. Suppose if you are not specifying a cluster and moving ahead, then the Kubernetes will apply a default service type that is cluster IP itself. Okay. Now, once the type is also defined, you need to specify pods whenever you will be creating services. Except node pod, you need to specify two pods for cluster IP or load balancer. For node pod, you will have an extra pod that you need to define that is called node pod that you can access from your local environment to access the node environment. Okay. Now, as you can have multiple pod, so can have only one pod. The pod inside the cluster is running at 80 and I need to map it to my target pod 80. Now, once it's done, I will apply this. Now, before apply it, what I will do, I will apply my pod label to app nginx if we haven't done it, but I can verify it. Can check with kubectl get pods wide. So that will give the details about their IPs also. So it's crashing, so leave it as it is. One of its container is crashing, so leave it as it is. If I want to check the details about a specific pod, I can go ahead and type kubectl, then describe pod, and then pod A, so that I can check whether the label is assigned to it or not. So I will go in here and I will check for the reason. Okay, so the reason for the second container is terminated with the error 1. Not sure why. For Nginx 1, it's running, so we are good with it. The label is already assigned to app Nginx, but suppose if your label is not assigned, so how you can assign a label using imperative? So you can type kubectl label pod. Then you need to specify your pod name, that is pod hyphen a, and then what is the label. So app equal to nginx. So using imperative, you can also apply label via use of imperative command. As I already have it, so I will cancel it and I will also clear my terminal. Now I will apply my service that I have created. So I have created my default service type, that is cluster IP. So let's try to create it. Let's try to apply it. kubectl apply -f cluster ip.yml. Now our service was created. So if I will type kubectl get service, so I have my Nginx cluster IP service running, and it has the IP of this one. So if you want to access your application, you need to go inside this cluster and then you can access via this IP. But externally, you definitely won't be able to access it. Okay. Now, what we will do, let's go inside the pod that's running our Nginx container, and inside that Nginx container, we will execute the C shell or bash shell, and then we will try to curl our Nginx service. So let's do that because we have attached our services. So here we have typed that, hey, go ahead and apply this service to anything that is labeled with app Nginx. But you can see both of our container is already labeled as app Nginx. So let's go ahead and let's verify it. For verifying it, I will go inside the cluster of pod A. So kubectl exec it interactive terminal. Then let's select pod A. Then I will specify container, and my Nginx container 2 is failing. So I will go with Nginx 1. And then I will specify hyphen bin and then bash. So I am inside my pod of my Nginx container. From here, if I will type curl Nginx cluster IP, so I will be able to navigate to the another container that is being run on the same service. That is the that is connected using my cluster IP. So as it is in different pod, but you are able to communicate it using the service that you have created, that is your cluster IP. So by default, whether they are in different pod also, they are able to communicate to each other if you are created any service. Okay. For now, I will exit from my container and I need to also delete my service. So kubectl delete -f so that I can illustrate another type of service, cluster ip.yml. Now my of Nginx cluster IP was deleted. Let's go ahead and let's understand about node port. Basically, a node port will expose the service on each node's IP at a static port. As we don't have any another node, we can connect it to our particular node that is basically ran by our minikube, and then we can assign any pod to it, and then we can externally access our application. So let's go ahead and let's try this. So I will go to my Visual Studio Code and I will create one file, nodeport.yml. The first line would be API version, and that is the v1. Then the kind would be the service. Then of course you need to assign metadata, and the name you are going to assign it, let's assign it to the name of Nginx node port. The next mandatory field is spec. Now within the spec, first you need to select a selector on which pods or environment, on which pods or container you are going to apply this node pod. So I will specify app equal to nginx, because on this label I want to apply this service to. Then I need to also specify type. The type that I want to is node port. So node and then capital PORT. Then I need to specify ports. Now within the port, I need to first apply the port on which my service is going to run. That is my node port is going to run. So let's take it as also 80. Then we have our target port. Now this target port is so within the container or within your app on which port it's been running. So it's running in 80 itself. And then I need to specify a node port. Now this node port is like what is the port that is going to attach to your external node. Okay. So let's give anything between 30,000 to 32,767. So I will give 33080 and I will save it. I will go to my terminal and I will list my content. So I have my noteport.yml here. So let's go ahead and let's type kubectl apply hyphen f then noteport.yml. I will hit enter and my noteport service was created. I will verify using kubectl get svc means service and I have my node port running and it is also telling that the 80 port was bounded to 30080. I can also specify kubectl get service and then nginx node port. So it will also give you the same. Now in here, as we have created our node port service, what I will do, we need to find the URL of Kubernetes service, usually of type node port or load balance in your Minikube cluster, and then we will open it in our default browser. So let's do that. Type Minikube, then service, and then the service name that was nginx and node port, right? That was the service of our node port. So if you are using node port or load balancer, in the earlier chapter we have also seen we use minikube service nginx node port so that it will open and find a URL of Kubernetes services that we have created here in our minikube cluster, and then it will open our default web browser automatically. So I will hit enter and you can see by default it has taken the IP of my minikube and then it has taken my node port that we have defined inside our deployment and it has given hello from nginx container, nginx 3 container. Okay, so by default it's automatically taking to the second port that is created. Okay. Okay, so looks like there is some issue on my VM and it's giving the error. I will cancel it. So I will cancel it and you have seen that using node port, it has exposed your port to your minikube cluster. So this is the IP of my minikube. I can also verify using minikube IP. So you can see that it's the IP of my minikube cluster. Now this cluster IP and then the port node, your node port, if you are trying to access them, you are inside your app. Okay, I will cancel it. I will clear my terminal and then in here I will delete my node port so that I can move to my load balancer service type for the illustration. So I will type kubectl delete hyphen f node port yml and my service nginx node port was deleted. I will clear my terminal and I will navigate to my VS Code. Now in the VS Code, I will close all these extra tabs here. And instead of node port, what I will do, I will create a service and let's give at lb.yml. The first line would be API version. Then the kind would be service that you already know. Then I will give a metadata. The metadata would be the name and let's give the name as nginx lb. Now it's need a spec also. In the spec, we will choose selector. in the selector, you need to select your app of Nginx. Okay. If you want to make it to a specific pod, then what you can do, you can remove any particular labels from a pod. So let's go to the B pod. Okay, I need to control Z it. At the same indentation level of selector, I need to specify type. The type is load balancer. And then you are right that we need to specify a pods. And in the load balancer also, we need to specify two things. That is the port on which you want to expose your app. That is the 80. Let's take it 80. And then you need to specify target port on which port your container app is running. So it's running also on 80. And then I will save it. I will go to my terminal and I will apply the configuration. So I will apply kubectl apply -f, then lb.yml. I will hit enter. Now my load balancer service was also created. Now let's verify it. Kubectl get svc. So my load balancer service is also there. Okay, it has signed with cluster IP, and you can see we haven't given any port here, unlike your node port. But if you want, you can also give the node port here. But in here, as it's a load balancer, so for external IP, instead of none, it's giving pending, so that you can attach your external cloud provider load balancer here. And whenever the traffic will be hitting to this IP, your app will be load balanced and then it will try to load balance it. Now, for now, what I will do, I will type and start Minikube tunnel so that I can use a feature of Minikube to assign an external IP to my load balancer service. So I will start my tunnel here. I need to provide a password for my sudo because it was not sudo. And now it's running. My Minikube tunnel is running and there are no error you can see. I will open another window here, and in here what I will type kubectl get service, and in the external service you can see that it has attached my Minikube internal IP as an external IP. Now on which our app is running, that is 31628. So I will copy it and then I need to specify our Minikube IP also, Minikube IP. So it's running on this one 31628, or I can also type Minikube service nginx lb, and it will start our browser also with the IP of my Minikube cluster and then the port that it has open as a node balance. If I will go here, so it's my nginx 3, and I think my pod A is crashing, means one of its container is not healthy, so it will not route it to that container. It's only routing it to nginx 3 container. But suppose if I will cancel it, and if I will go to my VS Code and if I will go to pod A, and then if I will try to delete my nginx 2 container, I will save it and then I will try to apply it. Before running it, we need to navigate to K8's network directory first. Then if I will list the content, I have pod a.yml, pod b.yml, and I need to reapply my pod a.yml because my second container was crashing and my load balancer was not redirecting to this one. So I will go here and then I will try to apply it again. So kubectl apply -f pod a.yml, and looks like my pod might be deleted. So let's try to first delete the deployment. So kubectl delete -f pod a.yml, and let's wait for our pods to delete and then we will recreate it. And then I will try to apply my file again and my pod might be created. I can verify kubectl get pods. So now both of my container is running, both of them are healthy, and this one is running my nginx1 container and this one is running my nginx3 container. I will go to my browser and in this same IP on which my load balancer is attached, if I will refresh, then you can see it is load balancing from nginx to nginx3. Okay, so that's how you can use load balancer as a service to route traffic from one container to another based on the users also. Okay, so that's it for the illustration or Kubernetes network. So that's it for this chapter. Let's meet in the next chapter. Till then, take care everyone. Hey everyone, till now we were using Minikube, that is good for our local and test environment for our Kubernetes, but it's not good for production environment because you might need more advanced stuff to work on your Kubernetes clusters. Okay, so let's discuss how you can use your Kubernetes and take it one advanced level above for your deployments. Now, before moving forward, let's understand what is Kubernetes work and what is your work while working with Kubernetes. So the first work of the Kubernetes is to create objects and manage them, then monitor, scale, or roll back your deployments based on the instruction given in the YML configuration file. The third one is Kubernetes utilizes the provided cloud resources to apply your config or goals. We haven't discussed it, but if you want to integrate your config file with your Azure or AWS cloud resources, and if you want to directly trigger a configuration from your Kubernetes YML file, that you can also do that, but that is a more advanced topic which we will not cover it yet. In terms of Kubernetes, what is our work? Our work is to create cluster and also master and worker nodes instances. So we were using Minikube, that is a tool that will provide a cluster with a set of one master and one worker node, right? But in your main production environment, that is not necessary that you need only one node, correct? Although in Minikube, we can configure multiple nodes, but that is also a most advanced topic. But even if you consider and create two or three nodes inside your cluster, you cannot take it to your development environment. The second work of yours is once you create your cluster and define master and worker node, you need to install tools that is required for Kubernetes to work, such as API server, kubelet, and other K8 server. Also, you need to provide load balancing and network file share file needed in your configuration file using the cloud provider technologies. So that was the difference between yours and Kubernetes. But on the overhead, you need to create cluster, master node, and your worker node and install all the required tools in there. So till now, we were using Minikube in which you install just Minikube and Minikube will create a cluster for you and also it will create one master node and one worker node to practice as a test environment or a local environment, right? But as we are taking it and it will also install all the required tools on them. Now, as we are going to cover a production setup, so in here we will create our own cluster, that is your environment of Kubernetes. Then inside it, we will define one master node and then also our multiple worker nodes. And also we need to install manually all the tools inside it. And how you will access this? Of course, if you have any setup in your data center or any cloud provider technology, if you're going to use for creating your cluster, you can do that. But suppose if you want to manage them locally from your laptop or from your workstation. So you might have remembered the first tool that we used was kubectl, and yes, you can use kubectl client to manage your own cluster wherever it is stored. Okay, now how that works, you might have remembered that while installing Kubernetes, we created a file called config inside your home directory and then .cube hidden folder. So that config file, we will try to read it by default what it says, and also whenever we will use any cloud provider technology setup, it will try to overwrite it when we will be authenticating it. So we will see this in the upcoming slides. For now, you have two options. Either you can use custom or your own data center, or you can leverage the cloud. Many cloud providers provide Kubernetes as a managed service so that you can use all of these. You just define how many nodes you want, and the cloud, that cloud technologies like Azure or AWS will install all the tools for you. Also, the benefit of using cloud is it is integrated with many services in their cloud itself. You can have your networking, you can have your load balancer set up in the background, and you can integrate directly with them. You can also use your own data center or a custom environment for your Kubernetes, in which in your own data center you need to set up your cluster on your own. Then you need to install, or first you need to create your master node and then your worker node or nodes, and then you need to install all the required tools manually on those two, means your master and the workers. Also, if you don't want to do or install all these tools manually, there are various tools available out there which you can use to even install all the tools, or you can get ready of your cluster without being manually intervention of installing all the required tools. For example, you have kubeadm, that is a command line tool that is designed to help you create a minimum viable, but it's a production grade ready. The second option is Kubespray. That is an open source tool that uses a Ansible playbook to deploy and manage Kubernetes cluster on various platforms, including the bare metal cloud providers and also the virtualized environment. And the third option, you have your cloud provider. So you can also use cloud to deploy and ready your clusters. All right. So I'm hoping how you can get ready and set up your own Kubernetes deployment environment for next. So for now, we are not going with the data center method. We will use cloud to get ready our Kubernetes cluster and also to set up our nodes so that we don't need to install all the required softwares like kubelet and kubeproxy manually on master and worker nodes. Okay, now if we are talking about cloud, so we have two major leading cloud technologies right now, which is AWS and Azure, and both of them provide a similar like of environment for your Kubernetes architecture. Similar like we discussed something called Azure ACI in our Docker course, in which we took our container to the production environment and we deploy in the Azure ACI. The Azure ACI stand for Azure Container Instance, which is basically provides you an environment to run your apps inside your containers, and with the help of ACI you can directly deploy your application as a production ready. Okay, and the similar like your Azure ACI, we have AWS ECS. The AWS ECS is stands for Elastic Container Service, which is a fully managed scalable container orchestration service that allows you to run, stop, and manage Docker containers similar like your ACI. So in the Docker course, instead of Azure ACI, you can also use AWS ECS. Okay. Now, if we'll talk about a fully managed Kubernetes service by cloud providers, so we have two options. Also, we have Google provided Kubernetes services also. The Azure AKS stand for Azure Kubernetes Service. That is a fully managed service via Azure for your Kubernetes deployments, in which you can set up and define all these things, all the parameters that is present in the Kubernetes, from scalability to networking, from setting up cluster to deploying your infrastructure or your containers. Both of the any managed Kubernetes service which is provided by cloud will give you flexibility of that. Similar like your Azure Kubernetes service, you have Elastic Container Services. Elastic Kubernetes Services, that is a fully managed service that simplified running Kubernetes on AWS by handling all the management of Kubernetes control plane and all these things in the background, similar like your Azure AKS. So in this example, we will take example of Azure AKS because I basically prefer Azure, but you can definitely go and practice on in AWS. All of these things, all the setup and all the installation of these things are pretty similar. But for now, I will select Azure AKS for my deployment. Now, this is a fully managed Kubernetes service from Azure, where Azure handles control plane setup and upgrades, scaling, and a node management. But you need to define how many scale you need. But if you want to select automatic scaling, so you can define your matrix, and based on matrix, it will try to scale up or scale down. We will see this when we will be on our Ubuntu VM on which our Kubernetes or kubectl is installed. Also, it gives you options for monitoring and security integration and even your networking integration. Now let's have a quick flow how you can use your Azure AKS for your environment. So first you need to create your cluster. So either you can use CLI using Azure AZ AKS create. So that is a bash command. Or else you can navigate to Azure portal and you can create your cluster manually. So we'll use portal to create our cluster manually. Then in our main environment, we need to show that easy CLI is installed so that we can run this command. Then we will use az aks get credential. Whenever we will run this command, what it will be doing in the background, all the configuration that was we were running earlier, it will try to replace in that file. Which file? That file which we were talking about earlier, that was stored on our home .cube, and inside that a config file. So whenever we will run this command, it will try to override from the default to all the configuration and settings related to my Azure. It will automatically replace it with this command. And then your kubectl is ready to interact with your Azure Kubernetes cluster. Then you can definitely run your kubectl apply f your configuration file and it's done. It is not going to deploy your configuration in your minikube or in your local environment. It is going to directly integrate and run inside your Azure AKS cluster. You can access your services via your load balancer or ingress. If you want to use AWS ECS, that is also pretty similar. You need to make sure that AWS CLI is installed on your local environment. Once you make sure, then you can go ahead and you can first create your cluster inside your Azure, and then similar like this command inside the AWS also you have that command which will replace all the by default configuration settings from default to the AWS based. Then you can apply your configuration and you can access your services similar like this. The commands may differ a bit, but they are pretty similar for all the cloud technologies. Now, while integrating your local environment to Azure or AWS, you need to make sure that you use basically not a CLI method to authenticate. as they are not good for your automation purpose. So if you want to use for your local environment, means you don't want to run it again and again, or you want to trigger a deployment on an event, so you can definitely use Azure CLI or AWS CLI to log in to your cluster by just typing easy login or AWS login. That is good. But suppose if you want to use for a CI/CD automation, then you don't want to define easy login or AWS login again and again. So how you will achieve that? So for that, even in your Azure or AWS, you will use something called a service principal. For setting up service principal, there are vast of instruction provided on the internet. Please go ahead and try to set up service principal instead of directly just logging to Azure CLI. There is one more option that is called a managed identity, in which the Kubernetes uses the credential for your resources to authenticate and to use inside your Kubernetes cluster. Suppose if you want to use a VM, your Azure VM, to use as a worker node, so you can use a system managed identity of your Azure VM to authenticate to your Kubernetes cluster and to allow it to work as a worker VM. Okay, so the managed identity is like a credential that is assigned to your resources, your VM or your whatever resources that you are going to use for your cluster, and it will try to authenticate via using that. Okay, so let me know if you are trying to integrate it with your service principal or managed identity. If you face any issue, please let me know. I will definitely try to answer that in my comment sections. Okay, for now, let's select our Azure AKS and let's deploy our infrastructure on the Azure. All right. Hey guys, I am on my Ubuntu VM where our kubectl client is installed, and also we were using our minikube to play as a local environment. So I need to first verify whether kubectl is installed or not. So kubectl version, so it should give me the client version. So yes, the client version is good, and no need to worry about this error that is telling that it is not connected anywhere. Now, if you are going to use Azure, so you need to also check for the version of Azure. So AZ version. So I have my CLI version of 2.775.0 as per of my current recording. But if you are using in your time, then it might be some differ. Also, if we are not going to use Minikube, so we can delete it, right? If you have any cluster running, so it will delete your minikube because we don't need it. So I will delete my minikube. Now once delete, I will clear my terminal and I will navigate to my Azure portal. Also I will open my VS code that was opened earlier, and in here I will close the recommendation, and for example we can take our pod a.yml, and instead of pod we can now use our deployment. Okay, and also we can use either a load balancer or cluster IP, but let's take a load balancer as an example. Okay, and we will select our nginx app for that. But before that, let's go to Azure portal and authenticate with your account. Now once you are authenticated to your Azure, if you don't have any account, you can go ahead definitely and you can sign up. You just need a debit or credit card for creating an account, and the creating an account is pretty simple. Also, if you are going to create a new account, you will get a free credit of $200. For now, I will go and select for Kubernetes service. If you cannot see it in here, you can also search for Kubernetes services. Okay. So on the top, you can select for Kubernetes services. Now in here, you don't have any cluster. So I will go ahead and I will click on create Kubernetes cluster. So I will choose my subscription. As I don't have my resource group, I will click on create new, and let's take it as new RG. I will click on OK. Now the Cluster preset configuration is basically it will customize your Kubernetes environment. Whatever the thing you will select here, it will automatically give the configuration or the resources like your CPU or RAM, how much it is going to use. For example, I'm going to use a dev or test environment. Let's give the cluster name, and the cluster name I will give at first cluster. Okay, and I will select my region as okay Central India, and I don't need to provide any of these, so I will leave it as it is. Now there is a version of your Kubernetes that you need to select, so I will select it as an automatic. For nodes also, if you want to select for a security channel type, you can select for the node image, or even you can use your custom security channel. Now the authentication and authorization is like your choosing RBAC for your accounts or for your Kubernetes cluster. So basically, if you are going to use much resources from your Azure to your Kubernetes cluster, so you can use of RBAC. I will click on next. And in here, you need to define something called a node pools. With your cluster, you will get your master node to manage your pools. But in here, you need to define your node pools. Inside here, it will by default give you a name that is not the name of your agent. So that is the name of your node pool. But if you want, you can select and delete it and you can create a custom. But as it has already created for us and given us a suggestion, I will click on it and I will see what other option that is gave us. So in here, it is a system pod. It cannot be a user pod. You can define a node pool name. This pool will consist of numbers of worker nodes or the configuration of your worker nodes. If you want, you can create another node pool and you can just connect your cluster to that node pool. The OS I'm going to use is Ubuntu Linux, and as I'm going to use Nginx, so I am good with it. I don't want availability zone, so I will unselect that because I'm using it for a local environment just for testing. Now the node size, you can use a less size, but as I want a faster deployment so that whenever I will deploy anything, it should deploy faster. So I will go with this size. Now the scaling method you get a auto scale. So basically it will automatically scale from the Azure. The Azure is smart enough to detect your workload on your cluster and it will automatically scale your node. Now you need to define what is the minimum node that you want and what is the maximum node you want. You can go ahead and provide more traffic to your deployment and it will automatically scale in or scale out your deployments or your worker nodes. Okay, so you can verify that using kubectl get nodes. For now, I will go to manual and I will select 2. Okay, and I will click on update. Now our disk configuration is also done. Now this is the OS disk encryption that is similar like whenever you are creating VM on Azure, you also get this option. Okay, so you don't need to worry about this. You can go to the next. Now in here, in the container networking, there are two options, Azure CNI overlay or Azure CNI nodes subnet. Basically, this CNI overlay will assign pod IP addresses from your private IP address that you will create, or thus if you have existing subnet, then you can use that. So it will assign you. Now this one was Azure CNI, that is not overlay, just Azure CNI, but now they have changed the name. Basically, this assign a pod IP address from our host VNet. Okay, the cluster VNet, which is based for workload where pod must be reached by other VNet resources. So if you want, you can go ahead. If you want networking related stuff to be integrate with your cluster, for now I will go with Azure CNI overlay. Okay, now these are the basically environment that you can define if you want a multi-cluster environment. Okay, Also for this Azure CNI node subnet, this option or this selection also affects whenever you are having a multi-cluster environment setup. Okay, so I'm good with it. I will click on next and all these things are looking fine. Now in here, we used our container registry to push our images in our Docker course. But suppose if you are deploying anything in your deployment.yml file, right? And suppose, for example, this image is on my Docker Hub. But suppose if you want to use image from your container registry, from your Azure container registry, so you can directly define or integrate your container registry in here itself. Okay. Now with it, you have your monitor options also, but in here, if you want, you can specify, but I will not integrate my Prometheus or Grafana monitoring insights for my cluster. So I'm good with it. I will also not want to enable the alerts, but if you want, you can definitely go ahead and play with it. Now the security, I will leave it as a by default. If you want to use, if you are going to use a etcd key value pair or even a cluster with which is having a certificate or password sensitive information, you can first store them in Azure Key Vault and then you can integrate Azure Key Vault to your Azure Kubernetes cluster. For now, I don't have, so I will go ahead. Now, this will create a infrastructure resource group, so leave it as it is. And then I don't need to provide a tags, and I will go ahead and click on review plus create. So first it will validate whether my selection is good or not. Now, once it has validated, you can click on create. So it will initialize your deployment. And now depends on what is the configuration you have selected, it is going to take some time. By default, if you are selecting a minimal resources and minimal nodes, it is definitely going to take around 5 to 7 minutes to deploy your cluster. So I will wait here to deploy my cluster. Till then, I will go to my VS Code and I will start setting up my deployment. Okay. So for here, I will select a deployment and these things are looking good. The label I want to give it as an Nginx app, and this one is also as an Nginx app. And the inside the containers, I can use an Nginx image which provide a web server, and we can use localhost 80 to navigate to our Nginx default page. But let's customize it. You already know how we can customize it. We can customize it using command option and we can change to our user share nginx html index.html page and we write our custom stuff, right? So I'll copy these things from my container section and I will go to my deployments and I will paste it in here. I need to make sure my indentation is correct. I need to also provide my container port, that is 80. That is the default port that my deployment will try to connect whenever it will try to boot up my container. All right. So my deployment is ready. Also, I need to make sure I need to also change here Nginx app. Now also in the service.yml, I have these things here. The API version is v1 looks good, kind is service, metadata, and the name. Let's give the name as AKS service because we are deploying it as a load balancer in our Azure. So AKS service is good. The selector is the tag that we have defined in our deployment.yml, that is Nginx app. So let's assign it to this one. Nginx app. The type we want to use as load balancer because we want to check the external IP and we will also try to access this in our browser itself. And the port, that is what the port we are going to use for our service, and the target port is like what is the port that you are going to connect inside your container. Inside our container we have port defined as 80. So let's take it as 80 itself. Okay. So our deployment.yml and service.yml is ready. I will verify my resources. So I will wait for it so that my cluster are getting created. So I will pause or fast forward my video until my Kubernetes cluster is getting created. And looks like it took around 3 to 4 minutes and my resource was created. I can go to my resource and I can see various options in here. Now that is the my cluster that is ready, and on the overview page it is giving you the difference here. It has also assigned a pod CIDR notification, that is the subnet that was assigned to my pod. The by default network that is assigned to my service was 10.0.0.0, that is the default. The container inside is not enabled. We have select the upgrade, that is this one. The security configuration is there, and we didn't select any extension or application. That is the setting for the nodes that you have selected. We have only one node pool, but you can create another node pool and you can attach to this cluster. Now you don't need to worry about fleet manager. If you want to attach a registry, so in here itself you can attach it. So in here you can click or expand on Kubernetes resources and you can see all the various things that we were seeing on the local environment. It is provided here itself. The namespace is like a advanced topic. You don't need to worry about that. Basically, by default, you create or define all the resources in the default namespace, whether it's on a cloud provider as your Kubernetes service or it is in a local environment. The namespaces are like an isolated environment that is used to isolate your Kubernetes deployment or resources for your environment. Okay, you can also create a new namespace from here itself or even inside your cluster here, and then you can deploy your deployments inside that namespace. Then you have your workloads. It will tell you what the pods you have, what deployments you have, what the replica sets you have, what are stateful sets, daemon sets, jobs, and cron jobs. Now, by default, that whatever you are seeing, that was created by my Azure. I haven't created anything yet. Okay. For example, you can see the deployments. I haven't created any deployments here. Azure Kubernetes Services created these 7 deployments automatically for me for get it working, and to create all these things here depends on what are the Azure administrator or Azure developer has defined their cluster how it should be work. Then you have service and ingresses section. Again, there are 4 default service that you got whenever you will create your cluster. I haven't created any of these. Then you have network policies. If you want to use your management network policy, you can add it here. Then you have storage. If you want to mount your extra storage, persistent volume claim, and then storage classes. Again, if you want, you can create from here itself. Then you have a configuration and even a custom resources you can create. Now, if you will go to the workloads and if you will go to deployments, so in here itself you can create your deployments, right? You don't need kubectl to install in your local environment and you deploy from here. You can directly go here and whether you can use a template starter application or even you can use apply a YML file and you can write your YML file in here itself. Okay, but I will recommend for using your kubectl client from your local environment and use your VS Code or any preferred code editor to deploy your things. Now, if I will use my terminal and if I will type kubectl get nodes, so in here you can see it is giving much error because all these things are not connected to my Azure or to my local environment. If I will use minikube start, so it will try to connect to my minikube cluster, but I don't want that. So first I need to authenticate with my Azure. Okay, now before authenticating to Azure, what I will do, I will open my another terminal here. I need to navigate to my .cube directory. So if I will list the file, So I will have a .cube directory here. So in here I have that. So cd dot cube. If I will list, I will have my config file. If you will see the contents of config file, so you can see it is pretty much null null null. If you still haven't deleted any minikube cluster, if you haven't typed minikube delete yet, so it will have bunch of things in here. But for now it's a default, it is not having anything here, right? So let's go ahead and let's use our another window. And first I will authenticate to my Azure which using easy login. Now it will open my browser in background and it will try to authenticate it. Again, as I have mentioned earlier, you can use your managed identity or service principal for this same. If you are going to use for a CI/CD automation, you should use a service principal. So currently I don't have my virtual machine, any of the virtual machine, but if you have virtual machine, then you can go to the identity section and you can see whether a system managed identity is assigned to it or not. And then in the command line interface, you can type az login hyphen hyphen identity and it will authenticate using managed identity. For now, as I am going to use as a local environment setup and I'm going to show you for a lecture purpose, so I will use az login method. So I have typed az login. Now it will ask for select my credential. As by default I have only one subscription, so it is showing me here. I need to type what is the subscription number you want to select. I will select one because I have only one. Then it has selected my this configuration as a default subscription. Okay, now I am good with it. The next command you need to run is az aks get credential. Then I need to provide a resource group. Again, if you are following this on Windows, you need to either change it to bash, means you need to use a bash shell, or you can use your PowerShell for this command. The equivalent of this one will be different. As I'm using a Linux, so it is using a bash shell, so I am running a bash command. That is not the PowerShell command. If you on Windows, so you need to change that. So resource group, and then I need to check what was the resource group. The resource group I had was new RG, right? So I will define new RG. Then I need to provide the name of my cluster that I am going to authenticate, and the cluster name was first cluster, right? I will hit enter, and now you can see it is giving something here that merge first cluster as a current context in our home DevOps cube config. Now, if I will go to my another window and if I will try to read my file, so you can see it has written various things in here. In the backend, it is authenticating like a SSH pair, right? And it is giving all the things in here like what is your cluster, what is the user, all these things in here. Okay, the API version and the cluster, all these things were written by my Azure to my config file. Now I can close this window and in here I will clear my terminal, and if I will type, so earlier when we typed kubectl get nodes, so we got error. But if I will type in here, you can see our two nodes are running, and these are my virtual machine scale sets. Okay, so if I will go to my Azure and if I will go to virtual machine scale sets, so you can see my agent pool scale set is up and running and it has two instances here. Okay, and as we have defined a manual, so we need to create our mm, if we want to create more, then we need to create manually more instance to my this scale set. If you have deployed using automatic, so it will create a scale set, but based on the metrics, Azure will automatically try to scale up or scale down. Okay, now in here we are good with applying the configuration, so let's apply it. If I will list here, so I have bunch of things and I want to apply deployment.yml and service.yml. The service.yml is my load balancer service, and this one will deploy a normal Nginx container with a custom message like hello from Nginx one container. But let's change it. Let's change it to my first deployment to AKS. Okay, and I will save it. Now in here I will go and I will apply this configuration kubectl apply f. Now whatever the thing that we are going to write or send the command, it is going to send the command directly to my Azure cluster. Okay, it is not going to trigger on my local environment. So kubectl apply f deployment.yml, my deployment was created, and also kubectl apply f my service.yml. My service was auto created. If I will go in here and if you want to also verify, so kubectl get deployments. So you can see it's running. Now you can also type kubectl get service. So it has my service running, and by default the Kubernetes service will be running, and it does not take time to assign a external IP because that was my Azure and it is already authenticated to my external IP, which was my Azure. Now I will go to my Azure and I will go in here. I will go to my cluster. I will go to my workloads, and in the deployments you can see my Nginx app is running. Okay, and it was created 1 minute ago. Similar, you can navigate to service, and the AKS service, which of type load balancer, is also running, and it has assigned a external IP. If I will try to navigate here, so it will give you the by default page of my Nginx here, my first deployment to AKS. So very good. You have, if you are seeing this using your Azure AKS, so you have also made it to your production ready, and you can go ahead and define and create a complex architecture. You can use your various type of API to create your deployments, and then you can deploy it using Azure. By default, as it was a load balancer, so it was able to take an external IP here. If you want to explore more about them, you can go to the workloads and all these things here. You can go to the Nginx app. You can have a YML look for it. So that is the YML look for my Azure related, right? Now this screen of the overview is similar like your Minikube dashboard. Now the overview or the Kubernetes services homepage of Azure is similar like your Minikube dashboard, in which you have various sections of namespaces, workloads, services, and ingress. Okay, so I'm hoping you were able to create and you were able to run your local environment written configuration file to your Azure AKS. Okay, now once you are done with it, it's very important you delete your deployments, else you will get paid. So I will go to my resource group and I will delete my resource group itself, so that it will delete all its residing resources from here, because I don't want that and I don't want to get billed for unused resources. So I am done with my illustrations, so I will delete my resource group. Okay, now I will move ahead. From here, where you can go now, first, you need to strengthen your core Kubernetes knowledge that we learned in this chapter. You need to focus on intermediate topics like your networking, storage, security, event scheduling, and config management. Many enterprise focus on more on config management like config map, secrets, and environment variable. You need to also make sure you understand the core concept of networking by understanding DNS, ingress, your network policies, service discovery, and CNI plugins like Calico and Planner. Then you need to get hands-on with the real deployments. First, practice on Minikube that we did earlier, then Minikube or Kind locally. Then you come to Azure Kubernetes services, practice them on the Azure, or if you prefer AWS, then prefer on the ECS or if you prefer Google, then go ahead and practice on GKE and try to deploying a multi-tier web application in which there is something called front end, back end, and also DB. Then try to deploy it on the production environment. See if you can deploy it, and you can send traffic from front end to back end and then back end to DB, and you store your password of DB and store data of your DB in the back end cloud provider services itself. If you want more practice, you can also add ingress, persistent volume, and auto scaling in there. The third you need to focus on is learn Kubernetes tooling and ecosystem. Like example, you can use learn helm, that is the package manager of Kubernetes. You can learn customize, basically that is the declarative configuration customization of your Kubernetes itself. So whatever you are defining, so suppose if you are typing kubectl get deployments but you want to customize it, you can definitely do that using customize. You can also use Argo CD or Flux CD. These are the GitOps deployment tool that you can try to use with your Kubernetes. Then the most important, you need to understand the CI/CD integration. You can connect your Kubernetes knowledge with DevOps. You can build and push Docker images using GitHub Actions or even a Jenkins. Then automate your deployments to Kubernetes via CI/CD pipeline. Then learn observability and monitoring. You can deploy and monitor app, but metrics and monitoring also plays an important role in your development. So you can use metrics tools like Prometheus and Grafana to have a look and to enable a continuous monitoring on your apps. You can have a logs enabled like Loki, FluentD, or EFK stack. You can also enable tracing for your app or your deployment using Jaeger and OpenTelemetry. Basically, you can learn how to debug performance issues, scaling problem, and or pod crashes. The troubleshooting plays an important crucial role when learning anything. Okay, so keep in mind that you focus more on troubleshooting and performance issue. Don't give up. If anything crashes, that happens. Even if I am illustrating for my own purpose, if I am even if I am practice for my lecture purpose, if I got error, then I don't need to leave that topic and move next, right? I need to keep handling and keep troubleshooting till then I fix the error. So that will also give me hands-on of various topic and to help in gain confidence in more advanced topic, and it will help me for being confident on that topic more. The next aspect you should focus on in explore cloud native ecosystem. As I said earlier, you need to expand your skills set around Kubernetes, especially on the managed services. So if you are done with them, you can focus on certification and projects which will gain you a confidence on getting to make your learning official and career ready. You can acquire certification and projects. There are official certification for Kubernetes also. Those are very advanced and very enterprise standard like CKA, that is stands for Certified Kubernetes Administrator. If you want to gain a knowledge of deep cluster management, there is also CKAD, that is Certified Kubernetes Application Developer, that is for application based Kubernetes skills. And that is also one more that is called Certified Kubernetes Security Specialist for advanced security related to Kubernetes. So these are the most security enterprise standard certificates around are there today. You can also build 2 3 products. You can deploy a scalable web app or even a app with a CI/CD, and then you can enable monitoring and auto healing on AKS or AWS EKS. Okay, then there are also various options for this. You can also learn infrastructure as code and you can integrate it with your Kubernetes. Once you can deploy to Kubernetes confidently, you can learn Terraform to provision Kubernetes cluster in the cloud. You can also learn Ansible for configuration automation and you can integrate your Kubernetes with it. For Ansible, I have this course on my YouTube channel. I will also try to upload a Terraform soon. So I'm hoping you are clear with it, how you can go from here after this basics course of Kubernetes. Let me know if you want a more advanced course on Kubernetes, which will focus on more on certificate called Certified Kubernetes Administrator. So that is for where to go now section, in which you can go to these various paths and understand and gain your Kubernetes concept more advanced. Let me know if you want a more advanced course on Kubernetes. If I will get a good response on this course, I will try to make an advanced course for my Kubernetes also. Okay. So thank you all. Thank you all for joining it with me. If you have just watched the lecture, no need to worry. You can watch them again and then you can practice all of these on your own practice VM. These lectures took much effort to create, so please help me with subscribing my channel, like to my content, provide me a feedback so that I can improve more. And let's meet in the next series of chapter. Till then, take care everyone.